Data science and any data-inspired and data-driven science is so critical right now. More and more decisions are made based on data. The amount of data that we gather every day and the insights that the data can provide us is just growing exponentially, and that is no exaggeration.
The market for data science and related areas like AI is booming.
It is so important to have women in artificial intelligence in the area of data science and also in leadership roles. It's being able to use data to solve issues and understand bigger problems. It's critical. And we need women in these roles. Every individual brings their own perspective. And so we need to make sure the entire workforce is represented.
And the good news is there's so many jobs and many different ways to combine their passion area and their skills in data science and get involved.
I would like you to say, what are the problems in the world that absolutely have to be changed? And, can you individually, given all the amazing background that you've had so far and all the education that you've got so far, what are the unique things that you can do to change the world towards that mission? And then think of the technology.
If that is going to become completely data-driven over time, then you can't miss that opportunity. You've got to join in and have your say.
If you're not looking at the data from all sorts of different angles, then you could introduce a lot of bias. So it's really, really important that we have around the table all genders, all races, all backgrounds.
We can't ignore social and structural problems. We can't just go in a corner and write some code and read math and then that's the solution, right? Can't do that. So we have to think about who is being affected by these algorithms.
Welcome to WiDS!
When we first started this conference, we never would have imagined that we'd be sitting here today with over 200 regional events. We've got over 500 WiDS ambassadors worldwide. Many of them are women, but we've also got a lot of men. And these are people who are just passionate about inspiring others within their community. We're in over 60 countries, and year after year, we're blown away.
Let's make this next decade the Women in the Data Science decade.
What I love about it is that growth is viral. That people will attend one event in one city and then they'll want to bring it to their cohort or colleagues the next year.
This type of industry can be done everywhere, so it should be accessible to everybody. And this is one of the reasons why I love that we are global with WiDS.
So we wanted to create opportunities for women to inspire, educate, and support women at many different times throughout the year. And one way that we decided we could do that was through a datathon every year, which is a predictive analytics challenge using real-world data. We have over 900 teams from 85 countries, and that's in every continent except Antarctica.
When we started WiDS in 2015, we had no idea this was going to be a global movement with tons of international events and a datathon and a podcast show and now outreach to middle school and high school. It's just been such a ride.
Our latest endeavor is to work on some materials that we can hand off to teachers in schools around the world.
This has provided a platform for literally hundreds of women, if not thousands of women, to have an opportunity to be heard.
But the truth is, these are really simple experiments, but they had profound impact because they empowered someone else to be able to do their job better or to be able to take that message.
5 years ago, when we were sitting around a coffee table thinking about what WiDS could be, I never in my wildest dreams thought it would grow so far and so wide around the world in just 5 years. What I'm most excited about is the next 5 years, because I think this is really just the start.
A very good evening to one and all. I hope all of you are safe and sound. This was the video of a conference of women in data science in Stanford University. And here we are today organizing WiDS Mysuru, an independent event to coincide with annual Global Women in Data Science Conference held at Stanford University and an estimated 150 plus locations worldwide. All genders are invited to attend the WiDS regional events, which celebrate, appreciates, and glorifies outstanding women doing extraordinary work across the globe. So, this WiDS event is organized by Ms. Usha Rengaraju. She is India's first women cattle grandmaster. She takes a strong initiative to organize and conduct talks and events that you come across on this channel. You can get in touch with her on her Twitter handle, that is @urengaraju. She leads 8 communities in Bangalore and Mysuru, as you can see. A few of them are GDG Mysuru, W2M Mysuru, TFUG Mysuru, and the list goes on. WiDS Mysuru is organized in collaboration with 4 major universities, namely NI Mysuru, VVCE, GSS, and GSSS. Each university has its own organization team. This is the organizing team for GSS, for NI Mysuru, for VVCE, and for GSSS. The organizers of these teams have played a huge role, and we absolutely appreciate their efforts and continuous support. Here is the core team of WiMLJS Mysuru, which works with its utmost determination and dedication in making these events a huge success. This team has done it all, from designing, marketing to anchoring under the guidance of Ms. Usha Rengaraju. We constantly organize such events every month and to keep yourselves updated, you can connect with us on our meetup pages. The links to the same are put up in the description below. So today we have a few of our core members with us. The first one we have is Samuel. So Samuel is a part of our designing team, and he will tell us how he made the WiDS Mysuru graphics and posters. Samuel, over to you.
Hello everyone. Am I audible, Nitya?
Yeah, absolutely.
Hello everyone. Good evening. I'm Samuel. I'm a co-team member of WiDS Mysuru, and I also design posters for the events. Designing good posters plays a very important role in marketing because when you basically tell the audience there's a sessions that's gonna happen. So it's very important to grab the audience highs during the other feeds among the other feeds that's there on the social media. So we do so by following good design principles, being choosing the correct color combinations, being having the good font styles, font colors, and placing the content in the right position. So by doing this, we follow a few other design principles. By doing these principles, we are able to do good posters. As a designer, it's very important to come up with creative ones, challenging. It's very challenging, but I also love to do so. The core theme of designing, according to me, is today you might feel that the poster which you have designed is the best one in the world, but after a couple of days or weeks, you might feel when you look at the poster again, you might feel that's the bad poster which you have ever created. So it's a iterative process where you feel a bit down sometimes, a bit up sometimes, and that's how designing is. You have to keep redoing the work. So the tool which I use is Canva. So it's a free tool, but few of the features are a bit paid. You can get the premium version of it, or if you're a student, you can get a GitHub a subscription of it, a GitHub student pack subscription. So it's a web-based tool, but there's also an Android app also where you can design the posters, and there's other things also to design. So it's pretty easy to design posters really quick. So that's how it is. So the tool is Canva. It's a web-based as well as Android one. So that's how I design posters for the sessions that's coming up. And yeah, so thanks to Usha Rengaraju ma'am for making me a part of the core team member. And it's also, I love spending my time with other core team members who really work hard to make the event possible. So yeah, so by doing this designing things, I really love doing it, and it also plays a very important role when it comes to marketing by grabbing the audience attention. So yeah, so that's how it is. So Canva is a tool which I use, so you can easily use it. It's very easy to follow. Yeah, so that's it. Yeah, thank you.
Thank you so much, Samuel. That was absolutely amazing.
Yeah,
And
thanks,
thank
Nikki.
you so much for coming up with amazing posters.
Yeah, thanks. Yeah, bye everyone. Yeah, have a great time in the sessions. Yeah.
Thank you. So now we also have another core team member with us. His name is Kevin, and pretty much it's him who puts together this whole event together. He has coordinated the event very meticulously, very nicely. So he's going to talk about WiDS Mysuru, the conference highlights, and all that. Thank you, and over to you, Kevin.
Hello, am I audible?
Yep, you are.
Okay. Hi everyone, I'm Kevin. I'm a computer science undergraduate in VVCE Mysore. I'm also an NCC cadet and I'm a data science enthusiast. And that's what kind of got me into this core team. And so yeah, I'm a part of this core team of which is common to three organizations or communities maybe. So that is GDG Mysore, Google Developers Group Mysore, then TensorFlow User Group Mysore, and Women in Machine Learning and Data Science Mysore. So we have kind of taken a break from that. I mean, conducting events for that. So we generally used to conduct events almost every weekend. But now we are focusing on this WIDS conference, which is this month-long event. So I'm going to just keep this short. So I'm just going to give a little bit of a highlight about the WIDS conference since we are nearly finished with the month event. I think we are on day 7, and in 2 more events we'll be done. And we conducted this event where we invited guest speakers from various places, and all of them being women, since this is a women-centric event. And we invited speakers to speak on various topics, and most of these women are really high profile, and they are professionals in the data science industry. And we made them conduct sessions where they speak about something like how data science is used in various domains or other industries like music or supply chain management or retail, healthcare, etc. So the sessions which the speakers have conducted were really amazing, and we had 3 kinds of sessions. So there were the talks. So talks were something like 20 minutes where the speaker spoke for about, they share the insights about their particular topics. And then we had workshops, which is for a slightly longer duration, around 40 to 60 minutes, and that is more on the technical side of things. And we also have a lightning round session, and that is more like more number of speakers in a shorter time frame. So like I think each speaker goes for around 10 minutes roughly. So yeah, these are the 3 kinds of sessions we have. And we pulled off this kind of event with where everyone have put some hard work from the core team. And we had, I think, over this month we have dealt with roughly around 100 speakers, and we had no community partners or sponsorships for conducting this event. And I think a couple of our videos have crossed over 1,000 views, and the core team has worked hard in making this event happen. And of course we did that under the supervision of Ms. Usha Rengaraju, and her efforts in making this events happen were paramount. Without her, this wouldn't have been there. And we also had support from 4 engineering colleges in Mysore, that is GSS, GSSS, NIE, and VVCE. They also conducted a datathon earlier this year, and we would like to thank this support. And we would also like to thank all the speakers who agreed to join us and conduct amazing sessions here. And that's it from my side. And also, I would like to add one small thing. As a male, I'm proud to be a part of the organizing team, which helps women being promoted. Since this is more about promoting women and showing that there are a good number of female professionals in the data science industry. So I do wish to see a time when people don't have to say something like, males are dominating this data science industry. So I hope to see a time when, women are equal to men. So we are soon coming towards that, and I do wish to see that day come through. And yeah, that's it from my side. We have a line of speakers ready for you, and without any further delay, let's get started. I'm going to hand it over to the anchor of the session, Nitya.
Thank you so much, Kevin. That was a really sweet message at the end. So basically, a huge shout out to both Samuel and Kevin for putting in their sheer hard work and determination in making this event a great success. And now let's just start the event. So our first speaker for today is Miss Rajalakshmi Borthakur, and she's the founder and CEO of TerraBlue XT, which is a globally recognized innovator with 20 plus experience of IT experience. She has a 20 plus year of IT experience. And she was inspired by her son's struggles with epilepsy to start her venture. And since starting in 2016, she has been able to create multiple innovative products in the area of neurology and mental health. Thank you so much, ma'am, for being here with us. It's an absolute pleasure. So I'll be handing over the session to ma'am, Rajalakshmi ma'am now.
Nitya, it's my pleasure to be at this event, and I hope you can hear me clearly.
Yes, ma'am, absolutely. Your voice is audible.
Okay, sure. So once again, thanks a lot, and a very good evening to all the audience that are out there. I shall now share my screen and get started with my presentation. So just give me a minute for that. Okay. Can you see my screen?
Yes, ma'am, it's visible.
Okay. Is my video also on?
Ma'am, have you switched on your video?
No, I have
your
not.
video is off right now.
Okay.
It's up to you. If you want to switch it on, it's up to you.
No, I don't want to switch it on. I'll just leave it off. Thank you very much. So I have a quick short presentation, and the topic that I have is on cognitive computing. And today I want to speak about a little bit about cognitive computing and the context around how we use it in our organization. So to start off with, the name of my company is called TerraBlue XT, and we build medical grade wearable systems to predict, detect, manage neurological and lifestyle diseases and disorders. The company started in 2016, and like you pointed out, Nitya, the main goal of the company when we started was to find a solution for epilepsy, to provide predictions about epileptic event, and in the process help provide early interventions so that the person who is going through an epileptic attack does not end up having that attack. Or if they are outside or they are doing different things or out in the swimming pool or on the road, etc., they could find a safe place and just go settle themselves before help arrives. So that was the main intention of starting the company. And by that, we wanted to help end users live a better quality of life, and also provide enough information to healthcare professionals like doctors neurologists, etc., so that they have more information about what's going on with their patients when these patients are not in front of them. They are in their homes or in the hospitals and so on. So that's what we started off with. And as we started working on the product, one of the things that we came across was that many of the people that have epilepsy also have underlying mental health issues. Epilepsy is a very debilitating disorder, and there is always fear and anxiety about when the next attack might happen. And that also contributes to people having a very anxious life. And so, though we started off looking for a solution for epilepsy, we ventured into the mental health area as well, because both of these things are connected. And as we went deeper and deeper into the field, we realized the quantum of the problem. It's a very big problem affecting the majority of the population, and hence, we thought that we should figure out a solution that could help enable people in their recoveries, and also help provide enough information to doctors for their diagnosis. Now, our vision as a company is to discover quantifiable insights from the human brain to make life safer. We call it one prediction at a time. And this is something that I, as a parent of a child with epilepsy, very strongly believe in. And this is what eventually, this notion around safety is what we eventually want to pass on to our end users in the long run. Now, coming to cognitive computing. So as a company, I guess we are in a truly cognitive space, because it is something that is used literally in our organization. So we bring together cognitive sciences and also AI to come up with a framework to address the needs of our end users. So not only do we deal with the human brain and cognition and behavior and emotions and stuff like that, we also use the cognitive computing technique, relying heavily on AI to build our technology stack and framework. Now, for the uninitiated, cognitive computing is, it's a kind of technique that, in very short, I could say that it is a technique that mimics the human brain. And it uses a blend. In this type of computing, you use a blend of AI, neural networks, machine learning, natural language processing, etc., to solve day-to-day problems just like humans. So in cognitive computing, I could summarize to say that the approach to problem solving is human-like. It tries to follow the patterns that humans adopt in trying to address a problem. And hence, this style of computing, I don't know if that's the right word, but this way of addressing a problem that mimics the human brain and the way we try to solve problem is referred to as cognitive computing. There are a couple of characteristics of a system that is based on cognitive computing, and they include being adaptive, interactive, iterative, and contextual. And these characteristics have been identified by the Consortium of Cognitive Computing Systems. And according to the definition that's given by them, the systems that are based on cognitive computing must be continuously evolving with an ability to tolerate ambiguity and unpredictability. They must work well with dynamic data in the real time or in the near real time. Now, applying this concept to what work we are doing in TerraBlue XT, we do collect data from our end users in real time, And we are building a system that is constantly learning from the physiological behavior and behavioral changes that are happening to our end users. The next characteristic is about being interactive. And this notion stems from the fact that cognitive computing systems must interact easily with end users and also with the ecosystem. For example, when end users put on our device, the device is context aware. It knows where the end user is, and it also knows what is in the vicinity of the end user, and it communicates seamlessly with its ecosystem. In our case, it could be servers, processors, other connected devices, cloud services, and so on. So the third thing about a cognitive computing system is that it needs to be iterative. And this is interesting. It means that a system based on this technology should be able to find additional sources of input for their own if there is a requirement. They must return information that is suitable for the specific application. Now, what this means in terms of implementation is that suppose an end user, one of our end user is wearing our device, and for whatever reason, we are not able to sense the location, or we are not able to provide the caregivers information about what is happening to the end users. Maybe because there is no, the mobile phone network at that point, the data capabilities are not there. So in that case, the system needs to be intelligent enough to find out an alternative source. And, hence this requirement of the system to think and behave on its own independently stems in. The next very, very important thing about a cognitive computing system is that it needs to be also contextual. It needs to understand the context around which different things are happening. For example, imagine our end user wearing our device. So the system, the backend system, needs to understand where the end user is, why he or she is reacting in a particular manner, and is the situation bad enough that the backend system needs to raise an alert, or can it let it go and just decide to keep a watch over the end user? So this kind of, elevates a cognitive computing system from a artificial intelligence system. So the ability to think and behave and provide information like a human is what distinguishes a cognitive computing system from other existing architectures like, say, AI. Coming to the application of our technology in mental health, and it's in today's day and age, mental health is becoming more and more important to address as an issue. And it's because of the changes in lifestyles, it's because of the pandemic, it's because of so many other factors that are affecting us, that mental health has come to the surface of the problems that needs to be solved immediately. And I don't know if you are aware, but it's so rampant that 1 in every 4 individuals have some kind of a mental health problem, with anxiety being one of the most common ones. Now, the other very interesting thing about mental health is that it happens to be the only field in the medical domain where there is no technological tools or tests to assist the caregivers, the healthcare professionals. For example, psychiatrists, therapists, psychologists, coaches, and so on. In mental health, doctors, psychiatrists diagnose the problems, by talking to the patient. So the entire process is very manual in nature. There is no blood test, or there is no a machine-based test that is done to understand what is going on in the end user's mind. And because the entire system is so manual, there is documented evidence that misdiagnosis is very rampant in the realm of mental health. There is also the problem of very less number of doctors in this field, and the number of doctors versus the number of people that are having a mental health problem is very disproportionate. There is also stigma associated with it, and because of this reason, not only people live a a kind of a poor quality of life, they are also hesitant to go out and seek care, because even if they go out, care may not be available to them. And because we work in the area of, we started off in the area of neurology, we saw the application of our technology in people that have underlying mental health problems in epilepsy. We thought that there could be a larger use of our product, of our technology, and hence we chose to work aggressively in this area to ensure that people that go through mental health issues are diagnosed in the right manner, and they are put on a road to recovery, which is very objective and measurable in the long run. So as a solution, what we have is a wearable, which is fast, objective, and accurate. It's a medical grade AI-backed system, and it could be used for mental health screening and for recovery management. What it means is not only we provide or help provide diagnostics for mental health, but we can also guide the recovery process. And I'm going to talk a little bit more about it towards the end. How the product works is the end user wears the device, information gets passed on to the phone, and then from the phone it goes to the backend cloud, or to the backend the cognitive computing engine. And there is always a continuous back and forth between the end user's device and the backend platform. So this product is supported by dashboards that could be used by doctors and their therapists, and for the patients, for the even the general people that are using our device, we have a recovery focused app, which means that we are not telling users how anxious they are all the time. Rather, we are telling them what does not make them anxious. We tell them about the things that makes them happy and comfortable, and we encourage them via our app to continue to do those activities that bring about calmness in their mind. How does all this come together from a technology stack perspective? Well, our products are hosted on, it's built on this engine. Shant and TJ are our product. We have different resources, databases, tools, data sets, libraries, etc., that is used in this engine. In terms of frameworks, we use Keras, PyTorch, TensorFlow, etc. And in terms of infrastructure, we are building an infrastructure for big data, because we take data in real time and we take data in like milliseconds. So we need a very big cloud and big data based infrastructure in the backend. Because we also deal with hardware, we also need to build an IoT infrastructure for the management of the assets. And of course, there has to be a huge security infrastructure in the background, because this is all personal data. And this is all data about human emotions and behavior and logic. And it is also medical grade data, and hence security plays a very, very important role in this whole thing. So coming to what are the different things that we see using our technology? Well, first of all, we understand states of mind and the traits of mind. And mind you, in the background, when we do try to understand states of mind, we are driven by logic that stems from cognitive sciences, that stems from neurology. So we need to blend in the medical aspects of the brain with the computing aspects to be able to say that somebody is feeling very calm right now versus somebody is not feeling calm or they are feeling agitated. With the help of our technology, in real time, we could see the shift from one state of mind to another. For example, suppose one of the audience is wearing our device and I am their, say, doctor. I would be able to see as I speak, how is my audience reacting to me? If I see that my audience is not interested, then maybe I could change my tone or bring in something to make the audience more engaged with me. So these kind of things where we are tapping into the current scenario in the end user's mind is one of the core components of our work. The next thing that we get to see is also recovery and emotions. So we get to see what kind of emotions do a person mostly dwell in during her days and months and so on. We get to see if something is building on. We get to see the evolution of something like a depression, something that could evolve from a sad state into something like a clinical depression. So our technology enables us to chart that path. The next thing that we get to see is long-term behavior change, which is like, for example, I'm speaking to you right now, I am in a particular state of mind. But if, you were to figure out what my state of mind is in the long run, what is my long-term behavior, then in that case, you will have to study my trait, or this is my long-term behavioral characteristics. So the short-term change, or the state change, could be very temporary in nature, and the trait is a long-term trend. So it's when doctors are doing therapies with their patients, it's very important for them to understand how an anxious person has moved into a calmer state. So if the therapy or the medicine is working, then the doctors will get to see real time that the state of the person is shifting into calmness. And this is a behavior that this person is sustaining for a longer period of time. And if the person is able to sustain that state for longer, that means the therapy or the medication might have worked. And based on that understanding, doctor could be able to make appropriate changes to the patient's medications and schedule. So here is how anxiety looks like. Interestingly, we are the first company in the world that is medically able to identify the distinction between anxiety and calmness. And our publication in this topic is going to come out soon. If you are interested, please write to me or follow me on LinkedIn, and I shall be happy to present the evidence to you. So anyway, so this is how anxiety looks like in the short run. The image on the left hand side here is the state, which is like right now how somebody is feeling. And on the right hand side is the trait. This is the long term behavior of the person. Both show that the person is in an anxious state. This is how calmness looks like. And you can see that the plot is very different. Here it is very, spiky. But on the other hand, here this looks quite calmer. There are less spikes. And it also looks very different. And even in the long run, you get to see that it looks very flat. The blue line is invisible. So it gives a good indication that the person's nature has started changing. Whatever medication or whatever intervention is being done to them, that's working for them. Now, the other very interesting thing that we get to see again in real time, again as it happens, is the experiences of people. We get to see like there could be people who could be very calm, but they may not be happy. And chronically not being happy is not a good thing. It could lead to depression, and hence this needs to be addressed in the right manner, in a very sensitive manner, as soon as possible. What's important, what's interesting is that we are able to pick out this distinction. So as you can see on the left hand side is a plot of a person who looks calm. He's got a flat kind of a plot. But on the right hand side is the experience plot. And you can see that most of the points of the person is on the left hand side on high negative and low negative. So as again, this is something that we get to see as it happens and in the real time. So as we are interacting with the person, we see that they are beginning to dwell more on the negative side during a conversation. Then very gently, we can move them to a positive side. You see all the points have moved to the right hand side now. Here, the person is calm, but the points are here on this side of the plot. They're mostly on the negative side. But in this one, because of some change in communication or in dealing with them, their points have moved to the more on it started moving towards the positive side. And when somebody is going through hopelessness or chronic sadness or depression, our goal is to help them be on the positive side as much as possible. So this is the amazing power of our technology, where we get to see what is happening in their minds and also guide people to be on the positive side of things, live more positive experiences with the help of different therapies, games, interactions, and so on. So coming towards the end of the presentation, so what is it that our technology addresses? What is the capability of a cognitive computing system in the area of mental health? Well, the answer is, first, it helps us to see the state of minds of the users. For example, the levels of stresses, evolution of stresses, different kinds of emotions, anxiety levels, recovery levels, and so on. We get to see what are the trigger factors, what brought on this change in behavior of this person. If a person is angry all the time, then we get to understand why a person is angry all the time and what could be done to make sure that the person becomes calmer. The next thing is we also get to see what is the degree and the gap between a negative and positive emotion fluctuation. Now, this is something very important because in 24 hours, if a person dwells most of the time on negative emotions and negative experiences, it's likely that they would be having some kind of a depressive episode. And if we see this over a very long period of time, then we know that it might become chronic. And sometimes we see that people can fluctuate, move between negative and positive, quite a bit throughout the day. And this is normal. As individuals, depending upon the context that is presented to us, we may shift between a positive or a negative state. But it is something to think about when we are mostly in a supercharged state or in a super sad state, right? So these kind of insights come from our technology. We not only see the bad things, we also get to see what relaxes users. And at a second and minutes level, in a real-time manner, moment by moment, we get to see the emotional states of the end user. And based on all of this information, we can forecast the user's behavior, or we are going to forecast the user's behavior. Now, what does it mean? Well, if we are dealing with somebody who has psychosis or who is prone to aggressive behaviors or anger, or bouts of very severe depression, then going by the information that we have in our hands, the patterns that have been identified by the cognitive system, we may be able to say how, in what manner, or in what way this person is going to react in the next hour or next couple of hours and days and so on. So what I just shared with you was a very brief a case study on cognitive computing and how it could be used in the area of mental health. This is actually a very, very big subject, and I've tried to simplify it as much as possible. But it is a very complex subject because it is not just engineering or data science at the end of the day. It is also about understanding human behaviors. It is about understanding all the softer sides of being a human being. And there is a huge element of neurology and mental health science that comes into play. And the coming together of the medical side and the AI side is what makes our system very unique. And to create it, we have to work in small building blocks and iterate over time, and then come up with something that is acceptable and relevant for end users. Before I leave, I would like to leave you with a message that the cognitive computing field is very interesting. As data scientists, you will get a chance to probably work in this area. You can apply for internship in our organization as well and find out what's going on and contribute to something that is going to make the lives of people better and happier. You are most welcome. But the message that I want to leave you with is that what I've learned through the work that we have done and through our studies with the human mind and human cognition is that every single second of our life, every single minute, we are given a choice to decide to be anxious or not to be anxious, to be happy or not to be happy, to react or not to react. It is always a choice. And what we have learned from our technology is that if we choose to be on the positive side, on the happier side, it's difficult to be happy, but if we make an attempt to be on the positive side of things, then it not only makes us lighter and calmer by the end of the day, but it also leads to great physical benefits for our bodies. So please think about it. Please feel free to write to me. And with that, I would like to thank all of you for listening in. And I look forward to coming and talking to you when the pandemic is over, maybe physically. Thank you so much. Bye-bye.
Thank you so much, ma'am. It was indeed a very interesting and very relevant, not only in the case that, obviously the data science part of it, the technical part, aspect of it, but as a whole, how it's affecting the society. Right now we're trying to give mental health as much as importance that we do give to physical health. So that was absolutely amazing. And I think it's one of the need of the hour. Sort of a technology for the coming generation as well. So thank you so much for being here with us.
My pleasure. Thank you so much.
So now I will be handing over to my co-anchor Ganya, and she will be introducing you to our next speaker.
Hello, good evening everyone. So without any further delays, I'll be introducing the second speaker for the day, that is Shreya Khare. The topic ma'am will be handling is deep learning systems for voice recognition. She is also like advisory research engineer at IBM Research. I would like ma'am to take over the session.
Hello, good evening to all. Welcome to today's workshop. I'm Shreya Khare. I work with IBM Research Lab as an advisory research engineer in speech and language group. In today's session, I'll be talking about a speech recognition system. I'll be giving you an overview of what a speech recognition system is, what are its various components, what are the various methodologies of feature extraction, acoustic modeling, language modeling, what are the various tools and resources that you can utilize to build your own speech recognition system. So let's get started. A speech recognition system is nothing but a system that translates spoken utterance into words, syllables, text, etc. We have seen a lot of applications of speech recognition systems, right from YouTube captioning to smart devices, even in the traditional era, in the older world, dictation systems were very popular by doctors, where they used to record the details of the patients at a very fast with the help of speech recognition systems. We used to have voicemail transcriptions, and we have definitely seen that those voicemail transcription systems and dictation systems were not very accurate then, but are now very accurate. So the speech recognition systems have built a very good quality till now, and definitely it's going to improve further. Speech is one of the most natural ways of a communication. It is not dependent on the person, whether he's illiterate or he is literate. He can easily communicate through speech. Hence, it has a wide range of application. In the current scenario, wherein we want to go completely contactless, we don't want to touch any surfaces, speech plays a very important role. Just imagine if I have a speech recognition system installed in my lift, I don't have to take the trouble of wearing gloves or using a toothpick to touch the lift buttons, or some new solutions which people have come up, right? We don't have to. We can simply use a speech to navigate through the lift, and hence, with time and with more needs, an accurate speech recognition system is the need of an art. Now let's discuss what are the various challenges that we face while building the speech recognition system, or what are the various aspects. So I have bucketed it into 4 points. First is the style. A speech recognition system might recognize a conversational voice. Conversational voice is something that I'm speaking right now. It's not read. It is something that I am thinking while speaking. It has some disfluencies. It's more of a conversational in nature. It has got a lot of thinking process going on. Then the other style of speaking is formal, wherein, suppose right now if I say challenges in ASR, that's a formal speech. I am saying this by reading the text, so I know what I am saying. I don't need to think. I don't have any processing time to take place. So that's a formal speech recognition system. So whether a speech recognizer is able to recognize a conversational speech, that's more challenging than formal, is a big challenge. Most of the systems right now are built to recognize formal speech and not conversational, but there are some aspects, there are some systems which are looking around on how to make them recognize conversational speech as well. Then the next category comes is the continuous speech recognition or isolated speech recognition. In continuous speech recognition, we want to recognize what we speak. As I speak, I want the transcription to be with me. Whereas in isolated speech recognition, I just want to recognize certain commands that I give. Say, for example, I say turn off the fan, switch on the light. etc. Right? Those are the certain commands that I want the speech recognizer to identify. That's isolated speech recognition. And what a speech recognition system will do is will identify these commands and enable certain devices. For example, when I say turn off the, like Alexa says, play the music, it recognizes play. And it knows what action it has to perform when I say the word play. Similarly, turn on the music, turn on the fan. It knows what it has to do with the word command turn on. So it has to activate certain things based on the command turn on. So these are these are the difference between a continuous speech recognition and isolated speech recognition. Another main challenge comes to a speech recognizer is the environment in which a person is speaking. Whether it has a lot of background noise. Right now when I'm speaking, it doesn't have a background noise. So it might work well. But the moment if I have some loud music playing in front of me, we as humans also tend to make it difficult. And hence, imagine how difficult it will be for a speech recognizer to recognize what I'm speaking. So background noise is a very important problem for a speech recognizer to handle. Then comes the channel conditions. The microphone that I'm using, the quality of the microphone that I'm using. It might introduce certain noise. Okay? So that's another set of challenges which the environment introduces and makes it difficult for a speech recognizer to recognize speech accurately. Then another comes the speaker characteristics. A lot of times a way a person speaks, like how I speak might be different than what you all guys speak. The rate of speech between the rate of the words that I speak might be different, how I pronounce might be different, my accent might be different. If I have a different emotional state, I might speak differently and a speech recognizer might not work. If I am very happy or excited, it might be that the speech recognizer is not able to recognize what I'm saying. But whereas if I say that in a more of a calmer tone, with more of a peace, maybe it's able to recognize. And same, if I say that in a lot of anger, it is not able to recognize. So the speaker characteristics is something also which a speech recognizer has to deal with. And that introduces a lot of variability that it has to handle. Another variability that it comes in speech recognition that it has to handle is large vocabulary and absence of non-word boundaries. Large vocabularies, like right now if I want to do a continuous speech recognition, I can speak anything. If I started speaking in Hindi or I start speaking some language, I would expect a speech recognizer to recognize. So the vocabulary has completely blown. And similarly, when I want to go to a particular domain and do it, suppose if I want to recognize speech of words like builder, property, or some medical domain related words, it might not scale up because it has never seen that. Since it has never seen that, it is not able to recognize it at all. Then some more ambiguities that speech recognizers are not able to handle is with for words like, if this example that is flashing on the site is whether I say ice cream or ice cream. If I say I want ice cream and speech recognizer generates this transcript for me, I want ice cream, the first one, that is scream, the shout. I would be like, what? I'm asking for ice cream and it's transcribing, I want ice cream. So that's an ambiguity that it has to learn to distinguish, because if it's the preferred context is I want, it should convert it to ice cream and not ice cream. So this is something very difficult, right? And how we make machines do that is a bigger challenge. So let's see what a traditional speech recognition system used to look like, and throughout the talk, it would be very nice if you guys can appreciate how a traditional system has now changed and has evolved as an end-to-end system. So in a traditional ASR system, there were these components known as acoustic model, language model, the lexicon, or referred to as the pronunciation model. There was this feature extraction component, and then there was the decoding. So decoding is something very simple. Given a WAV file, I have this model trait, I want to decode. So that's fine. with some fancy search algorithm in there. So all the magic that happens in speech recognition is in defining a good acoustic model, having a good pronunciation model, having a good language model. Obviously, features are equally important, and that's what creates the complete magic in the systems. So let's go one by one, understand the details, and we'll also understand how each model has evolved from a more of a traditional system to a deep learning system. Okay, so the input is a speech file, simple speech waveform as shown over here. And we want to extract some features out of it. Traditional machine learning pipeline. So what typically these features are something that signal processing experts have defined, like they look at a certain frequency components, and the way when they design these features, they want to mimic the what human ear behaves, right? How a human ear behaves when it listens to some speech or some sound. So they want to capture that behavior and capture and define certain features. So spectrogram is one such feature which converts the audio to, which represents the audio in the frequency component. And on that, we apply some feature extraction. The most popular feature extraction algorithm has been Mel filter capture coefficient. We'll be discussing about that in the later slides. The next component, I would say, after the feature extraction is the most important is the acoustic model. Acoustic model. The aim of the acoustic model is, given this frame of sound, what is the most possible character, also not the character but the unit of sound that is there in this frame. So in speech we call that a phoneme, that is the smallest unit possible sound. So given the speech frame, what is the possible unit of the sound that is present in this frame is what is the purpose of the acoustic model. In the traditional systems, in the acoustic model was defined as a Gaussian mixture model that's like a left-to-right Gaussian mixture model with some number of states and mixtures, and that used to model that given this frame, what is the possible sound unit, that is the phoneme. And then there was a language model which used to learn that, okay, the speech recognizer has recognized something till this word. What is the possibility of a next word? If I say, I want to eat ice cream, it should understand the scream in the context of my previous words and convert it to scream with the S-C-R-E-A-M, not the cream, ice cream. It should understand the context behind it. So that's what is enabled by a language model. The gap between the language model and the acoustic model was bridged by a pronunciation model or a lexicon. So now lexicon is you can consider as a lookup table that maps that for this word, this is the pronunciation. So if I have the word smile, the pronunciation is, it is composed of these pronunciations is what a lookup table has told, and that's what a pronunciation table. And you need a lot of experts, linguistic experts, to create this lexicon. And once you have these systems well defined, that's the acoustic model is defined, a lexicon is defined, a language model is defined, we have a model trained. That's so simple. Right? So the beauty lies in defining these components and orchestrating these components to transcribe a good speech waveform. Sorry. So let's go about the first step that we discussed, that is feature extraction. So with feature extraction, what we have just understood is what's a spectrogram we'll be talking about. Sorry, I'll first talk about feature extraction. What's a spectrogram? What is a MFCC feature? And what are filter banks? So let's get started. In feature extraction, we break the speech signal in overlapping frames. So for example, I take 25 milliseconds of window in the speech signal and I shift it slightly to the next window with say 10 milliseconds of overlaps or something, and I extract these frequency components or certain features out of it. And the reason to do this is because speech is quasi-periodic in nature. Right? Okay. So let's see further. So now the information in speech is mostly lies in the frequency distribution of the signal. The ear performs or mimics this frequency analysis, and that's why we are able to perceive that, or even we are able to listen between certain frequencies. If something is of a very higher frequency, we are not able to understand. So the information is probably encoded in the frequency distribution of the signal. And this is one of the visualization of the speech when it is converted to a time and a frequency representation. And this is known as a spectrogram. These are two-dimensional time frequency plots. The x-axis is time, y-axis is frequency. The intensity, the redness, that is the red thing that you can see over here, is the intensity that indicates the energy in the signal in that particular frequency band. So if I say that this is 2000, in this time step, that's the energy value at this certain frequency. So that's what it's indicated by this spectrogram. So just to get red in this image that we have shown here, red is the one which is having the highest value and blue is the one having the lowest value. There is no components present almost there for those frequencies at that time step. So it's kind of a silence, and then we have certain activities taking place between for say less than 5,000, not much activity, above 7,000, very little, and that's how we capture all this information in a spectrogram. Now, we understood in the previous slide that the phonemes are one of the basic speech sounds. So I have just got the plots of the spectrograms of the various phonemes, and you can easily understand that there is a distinction that is captured in the spectrograms across all these phonemes. So each phoneme has a distinct set of a frequency band, which is termed as formants. And feature computation converts this signal into the representation as shown. And using this identity of the sound becomes clear. Okay, so now we have different level of features. Till now we just explored spectrogram. Now we will see what is MFCC spectrum. So till now we have talked about time domain waveform. That's this. We convert that into spectrogram, and then we have the MFCC spectrogram. MFCC spectrogram is computing filter bands and involves somewhat the same procedure, where in both cases filter banks are computed with So MFCC and filter banks are two different features, and it's more of a way of capturing the human perception. And these are the various steps on the right which indicate on how we compute the MFCC features. I have a notebook which is telling about the details of all the steps and what is happening, which we will be going towards the end of the section. And it computes the filter bank, and MFCC involves somewhat the same procedure, whereas in filter banks are somewhere kept at this stage, and after that we do some additional steps to compute your MFCC. And the reason I have kept filter banks in MFCC is just to have an understanding of why in traditional systems MFCC were more important, and with the deep learning systems it is the spectrogram. Sorry, it's the filter banks that are very important. So before going to that, let's understand what an MFCC spectrogram is and what are the various stages that are needed to compute them. So pre-emphasis, windowing, Fourier transform. I will be skipping to the details of this. I'll be tightly coming to the filter banks. So filter banks means applying triangular filters on the Mel scale and compute the power spectrum at each frequency band. it is the idea is to capture the non-linearity of the human perception. How? By being more discriminative at the lower frequencies and less discriminative at the higher frequencies. And after computing this filter bank, we apply DCT, that is, we remove the decorrelation by applying DCT and obtain your filter banks and obtain your MFCC features. And before doing decorrelation, we have our filter bank features. Now, all steps that are needed to compute filter banks are primarily because we want to make human ear. MFCCs are very popular in the GMM, HMM world and not in the end-to-end speech systems. The reason being deep networks are very less susceptible to highly correlated input. So there is no point of removing the decorrelation. So there is no more the necessity to apply DCT and then there is less loss of information. Though, I mean, sorry, I should not say it's less loss of information. But, okay. How do we build an end-to-end speech recognition systems? There are a lot of these open source libraries which is based on Chainer and PyTorch, and one of the most popular ones recently is ASP.NET. Kaldi is another tool which was more used to build the traditional pipeline. And folks who after today's workshop, you can go through ASP.NET and build your system. I would suggest besides ASP.NET also there have been other libraries, other PyTorch code bases, Wave to Letter, Espresso, which you can use to build such a system. ASP.NET has a lot of examples with it. You can go reuse few of the examples, then plug in your own data, and it becomes extremely easy to build a speech. We all need data set, and definitely for building a good speech recognizer, we all need a good data set. So OpenSLR is one of the data set few Indian languages data sets also available over there. And if you want to build those systems, you can go and look out for data over here. Definitely, if your data needs are not satisfied by OpenSLR or other speech open sources, you need to go and collect your own data. But to get started, you can use OpenSLR and just build few speech recognition systems. Okay. So after understanding the tools and the various feature extraction, let's now understand what are the various systems in the end-to-end world and how it has slightly changed. So this was more of a traditional pipeline that we had seen earlier. We were feature extraction, we had a frame classification, and the sequence model that was done by your acoustic model. Then you had a lexicon and a language model. And finally, you were getting a sequence of words, which is the best possible word sequence that you were getting. Right. So let's first discuss about language modeling. The goal of the language modeling is to assign a probability to a sentence. For example, in the case of, and this is language modeling is a technique which is not only used in speech recognition, it has been used in machine translation, spelling correction, etc. This is given the word, what should be the possibility or the probability of the next word. So given wins, given high, whether it should be wins or it should, given the next word is wins, whether the previous word should be high or large, we need to decide. High wins tonight or large wins tonight? Which one has a higher probability in the construct? So these aspects are what a language model system captures. I hope I'm doing good on time. Let's continue. Sorry. Okay. So the goal is to compute the probability of a sentence or a sequence of words. That's what a statistical language model is about. And the thing that we use to compute is what is the probability of the next word given the first 4 words. And this model, P of W, is called a language model. How do I go about computing the joint probability? We all have read about chain rule of probability, and that's what is the basis of a language model. Can we just count and divide? No. Probability, it's so transparent that we just count. It's what? Count the above numerator and then count the denominator and just have the statistics based on that is what we need to answer. Is that just sufficient? That's what a statistical language model does. Just so here we just had a word, complete sequence. Here we have whether we want to condition on the previous words. In case of the bigram models, we conditions on group of 2 words. In a trigram, we see a context of previous 3 words. Now that was a statistical language model that was based on the count and the probability. Now we come to an RNN language model. The idea between while building the RNN language model is that it learns from the data. It remembers from the data. So given this sequence of words, it learns to remember what can be the next possible word. So that's what a RNN language model does. I am not going into the details of what a RNN language model is. The idea I wanted to have some content on RNN language model is to understand that earlier people were using a statistical language model, and now we have RNN language models which have played a very crucial role. So RNN is one such way to make those language models. RNN model is a language model in the latest end-to-end speech recognition systems. Okay. All right. So the way it learns is we feed words which are converted to one-hot vectors. By one-hot vectors, we mean that this word is present in the corpus. We convert the one-hot vectors to word embeddings, feed into the hidden states of RNN, and it finally learns this distribution from data. The output distribution is learned, which is a softmax of over the hidden states representation, and it learns the output distribution. Now we have seen a statistical language model, we have seen an RNN language model. The key idea comes in how to evaluate the language model. So the most important metrics of the language model is perplexity, and again it's based on the chain rule of probability, and it's just normalized by the number of words, and perplexity is the standard measure of the performance of the language model. So when you train a language model from the data, you want, before plugging it into the complete pipeline, you want to see whether the language model is good or not, you compute your perplexity. Besides RNN and the statistical language model, now in the recent world, there have been huge set of language models which are available. For example, BERT. If you want to build another ASR, you can go and use a multilingual BERT. You have OpenAI based some language models, and these are models which are pre-trained with huge amounts of data. So these are some other language models which you can utilize to improve the performance of your speech recognition system. Now let's come to what is acoustic modeling and how an end-to-end ASR system is designed, what's the encoder architecture, and what are the various loss functions. Okay, so an end-to-end ASR. The idea of an end-to-end ASR is that let the machine do everything. We should not have these individual components of feature extraction. We should not have an individual component of a lexicon, not have a component of a language model separately, but language model can still be a separate component. But the idea is to get rid of those individual components of feature extraction, acoustic model, and a lexicon. And how do we do that? And the idea came is because the lexicon was something that was manually curated. We wanted to let the machines build that and understand that from the data. So an encoder is something that processes the input sequence that we provide. Here, the input sequence is a speech waveform. It converts that into a representation, or technically known as a context vector or a thought vector of a fixed length. And that vector encodes a lot of information on what is there in the data or what is there in the input sequence. And then we apply a softmax and do a mapping to the character. So in an end-to-end system, we are mapping each frame or the speech signal to a sequence of characters. So given this X1 here, we want to understand, given this input sequence, what are the probable or the possible characters that can come in the output. So in end-to-end ASR, we remove everything. We just have this is the input sequence of speech frames and the output sequences of characters. How do we combine them and learn it? So in understanding what an encoder does, at a very high level, it tries to capture or say various layers of encoders or multiple layers of encoders captures the information in the input sequence and converts it to a hidden representation. And later on, we use a decoder, which takes this context vector as an input and converts it into a transformed output. Okay. So just to iterate now, encoders in the latest end-to-end models can be a RNNs, it can be a CNN, it can be a transformer. Now with this, we need to understand which is the best ASR model and which suffices our purpose or which handles the challenges that we want it to handle. RNN might not handle everything, a CNN might not handle everything, a transformer might not handle everything. So that's where we want to understand which model represents or fulfills our need. Okay, so the reason of using CNNs over here is CNNs are enabling feature extraction process. Very simple. So somewhat of a feature extraction part of the code is a feature extraction part of the pipeline is done using CNN, and we know that CNNs have shown tremendous success in the image world, and the same has been observed with CNNs in the case of speech. This slide, I'm sure we guys don't need to go into the detail. It's more about what are the various platforms that we can use to build. So if you're using ESPNet, we can use PyTorch or Chainer. If you want to use TensorFlow speech recognition based libraries, you can easily go and do. But these are certain popular deep learning frameworks that you guys can utilize. My personal recommendation is on PyTorch, but all are equally well. So you can just go on any one and choose and build your system. So now let's come into what a convolutional neural network is and what it does. So I used to have this very old example, which if you've in a few Women Day sessions that I talked earlier, a convolutional neural network, you can take it as in a dark room you go and you have a torchlight with you and you want to focus on certain areas and form the complete image of what is taking place in that room. That same example I would like to reuse to make you guys understand what a convolutional neural network is. So it tries to apply various filters and tries to capture the representation which is there in the input signal and convert it to features. So if you go to a dark room, try to flash torchlight. First, it will flash to a certain area and that becomes a small edge in the room. Then if I go further, I get something more combined with that edge and I try to understand that's a corner. Further I go distant back, I increase my filter size or I increase the size of my torch, it becomes to a particular room or a particular bed or something, and that's how I understand that's the image. Similarly, in the spectrogram, I give to my convolutional neural network, it understands what are the various formats or what are the various features that are needed, or we cannot really reason out that it's recognizing formats or not, but it tries to apply various filters and understand what are the various features that are important for this particular utterance to be recognized as that the transcribed output while training. For more details of convolutional neural network, you can refer to the link below. Then comes is the recurrent neural network. We want to have a certain memory to be given in the acoustic modeling time. That is, till now it has seen this much of phonemes. What next it has to come because it has to remember. So that context is provided by RNN. So recurrent neural networks have also been very popular in the end-to-end systems. Then comes in the attention mechanism, and that has really disrupted the performance of speech recognition systems. By disruption, I mean it has made it really, really good. So attention mechanism is also an attempt to implement this action of selectively concentrating. We guys, as humans, also have always said that if we selectively concentrate, we will perform better. So what we do is we make this thing, give this thing to our model and ask them to selectively concentrate on the relevant things that they need to transcribe that utterance rather than going on to the complete features or that the CNS computed. And hence the attention mechanism has shown a lot of improvement. Okay. Okay. So just going this, that the encoder, the context vector that gets created over here captures 3 categories of information. First is the encoder hidden states, the decoder hidden states, and the alignment between the source and the target. And this is what it learns pretty well, and that what you can see over here is an alignment matrix that captures the correlation between the source and the target. And while and that's what is the power of attention mechanism, that we can very good alignment matrix that you can see. Now, we have a new popular network which has come out to be very, very popular and has shown a lot of success, is transformer network. LSTMs and RNNs have this problem that they don't scale very well when the sentences are too long. The model often forgets certain positions. And also there was these compute problems so that the parallelization was not being able to implement it in the LSTM. And we wanted to model this long range and short range dependency. And hence all these problems or the limitations of your RNN models were overcome by the transformer networks. How does the transformer solve this problem of RNN? It tries to solve this problem by using convolutional network along with the attention model. Attention enables to boost the speed of how fast the model, because it tells you just to focus on only selective region. Almost the transformers have a similar architecture to the what encoders and decoders we have said. Just the difference is the transformer consists of, say, something like the most popular 6 encoders and 6 decoders. That's what a transformer network is, and I would recommend you guys to, if you want to really go on long utterances or you're not able to get good performances in your speech recognition system with RNNs, I would really recommend you go and try transformers, and it does really well. So this is what we have seen about what can be the various models for endpoint PSI. Now comes the most important aspect, is the loss function. What should be a loss function in the end-to-end PSI? You know that this is the given sequence. This is the output sequence. If this would have an interactive session, I would really have asked this question to my audience. But still going, since it's on YouTube, I can't have questions and I can't have an interaction right now. So let me answer this, that what should be the loss function and what's the problem with the speech that we can't use the loss functions as it is. So for example, if you consider a speech data set, We have a data set of audio clips and we have the corresponding transcripts. Problem is in speeches, we don't know which character belongs to which frame. There is not a guaranteed alignment possible. We don't know, so I might say forward, like that. And the output text is still single hello, HELLO. It just simply says, I have said hello with a lot of emphasis on E and L, and a lot of in my speech signal, there's a continuous extraction of hello of E. There's a continuous focus on E. And what is the text that I want to update with a single E? And if I say hello, I want two L's to come in the output. So there is this problem of alignment. So, and because of this problem of alignment, we cannot use the simple loss functions which are available. Because we have this issue that one character corresponds to 20 inputs in the 20 frames in the input sequence. Right? And this is a challenge that comes in the speech recognition system. Obviously, it is solved, but that was solved by a particular loss function, which is CTC. So CTC is just coming back to this. So what we have observed in the traditional pipeline, what was a frame classification that got converted to an encoder, and the sequence modeling got converted left by the CTC. So the frame classification and sequence modeling together are done as a task. Lexicon is completely removed. Frame classification and sequence modeling are completely done as a task together with usage of encoder and CTC. Now, what is CTC? CTC is connectionist temporal connection. When in speech, characters in the transcript do not align with the audio. That's what we have seen. And it might be that one word in the input mapped to 10 words in the output. And the purpose of the loss function is that for a particular input, we train a model such that the maximum probability assigns, so that for this input, it always gets the right answer that is close to the ground. So we want a very good loss function, and hence we figure out CTC has been a very good loss function. And so that since the model has learned to generate the right output with the help of the training data, at the time of test, it will always generate the right training data. So what's CTC? And how it gets handled? Okay, so I'm good with time. Let's see. So this is the last CTC, then we'll move to the hands-on session. I mean, not really hands-on, I'll walk you through what to and how you can use it. So just to sum up, CTC, what it does is it forces every input time, it is the input sequence xt, to align to some output. Now, as we have already discussed that in speech recognition, the input can have stretches of silence with no corresponding output. So for example, if I have this sequence, input sequence, okay, I have it mapped to CC AAAT. If I apply a simple logic of dropping replacements, right? In this case, it works because two C's I replace with a single C, triple A's I replace with a T, A, and then a T. So as repetitions drop out over here, collapsing repeats works for this example, whereas it won't work for examples like hello, because I want, in the case of if the input word is hello, it would, if I use this vanilla algorithm, it will convert it to hello. So CTC helps us in bridging this problem by introducing an epsilon token. So it introduces a new token to the set of allowed outputs. That's epsilon token. Right. Now this token, we can call it as a blank token also. And most popularly is referred as epsilon. So if your output sequence has two of the same characters in a row, then a valid alignment must have an epsilon between them. With this rule in place, we can differentiate between alignments which collapse to hello and those which do not collapse to hello. So using this epsilon, we're able to have this distinction of what is a valid alignment and what's an invalid alignment. So that's it all about CTC, and it has got its lots of advantages. That alignments between X and Y are monotonic in nature. They are many to one. Length of Y, that is the output, cannot be greater than the length of input. So that's the details and the maths of the CTC alignment. So what does it look at you? It just looks at the softmaxes that are produced by the recurrent neural network over the entire time step you are interested, right? And it finds the probability of the transcript through these individual softmaxes, and whichever gives you the maximum probability, that is what your best sequence is. And that's how CTC the CTC loss function is able to help you in predicting good speech recognition systems. Okay, so now, since we have all understood some of the concepts which are needed to build a speech recognition system, let's all apply all of this using the standard libraries, like ESPNet. So ESPNet, you can follow the documentation if you want to install. It's very wonderful documentation. I have set up a small collab notebook here right now for you to understand what are the various things that are needed. So first we need to install PyTorch and CUDA. The reason we are using Collab is because we need GPUs for training with efficiency. So Collab provides you one GPU free for you to use. So you can use that. If not, you can try on your CPUs. The training time will be slow, so all the installation setups are done, the compatible versions which do not cause any error there. So you can use this thing. Starting, I have given some code of feature extraction as we discussed in the MFCC pipeline. The primary need for this is to understand the need of filter banks and MFCC, how the features look like. And though the ESPNet, there is a code in this code to compute that. So you can easily use that as well. But for understanding into the details of what are the various stages of an FCC and the filter bank computation, you can follow the code given over here, where you are just plotting the wave file that is there. You are doing the pre-emphasis stage on the wave file. You are further doing some computation on to compact the signal, get to the windowing on it, applying the non-linear filter banks on it, and hit the filter banks feature. Here we're just plotting the filter bank of the spectrogram for a particular utterance that we downloaded, where then we have here we have taken the decorrelation over here by applying the DCT and negative MFCC. So the idea is to understand the difference between how an MFCC looks and how a filter bank looks, and hence to the newer system, to the end-to-end systems, we are feeding a filter bank. So now let's go about building a model in ESPNet. So here we have the ESPNet setup, which we already did above. We are just adding that to our environment path. Here we are playing with the AN4 recipe that they give. AN4 is a speech corpus, it's a meeting speech corpus. Here is just the dependencies that we want to use. And then we have our examples over here that we want to build. So this is how an example directory looks like. You have your local, you have your path.sh, you have your run.sh. You download all your data over here. How data looks like is like a wave file mapped with a unique ID over here. That's how you wave recipe. The details of making this wave recipe for any new data set you can find in the Kaldi documentation of your data. But the look of the wave recipe is that you have a unique identity and the path to which the file it is there, and you have your utilities which are this is a SOX-based utility or SPH2 pipe utility to convert into a desired format. Since the raw data in the AN4 corpus is of an HSPH, I'm using an SPH2 pipe utility. Then you have a text file which has basically your ID and the corresponding text. Then when we do stage 2, what it does is it downloads all the data. It does your feature computation over here. So I'm just scrolling this. Folks can use the same notebook or the default notebooks provided by the ASP.NET. So it says that it has successfully downloaded and untarred the data. I'm not running the cell considering the time, and so you can run the cells and just validate if everything is working and try it yourself. Then the stage 0 is data preparation, that is converting into wave recipient text files. And the stage 1 is doing the feature generation, that is computing the filter banks. Here we are doing filter banks with some pitch information also adding to it. So we have computed, we have run that, and we have computed that for all the files, and that gets dumped over here. Then we are creating our text data and converting that into features by computing, basically by creating JSON files out of that so that it is useful for newer pipeline. After this feature computation here, I'm just plotting how the final data JSON that we have, that we are plugging into our ASR train pipeline, that is the training pipeline of the module, looks like this, that we have generated in the above steps. And this is the corresponding MFC filter bank feature, which we have plotted. This gets plotted by loading from the file system, because in the stage 2, all the feature gets dumped into the file system. Now, in the third stage of the ASP.NET pipeline, we are training a language model. The AN4 recipe defines a very simple language model, a single layer language model with 300 batch size, and it's trained for 20 epochs. And when we run it, we after providing for stage 3, we run this, and this takes approximately about 2 minutes to run. The logs of this, you can see it in your train.log file, which gets created in your experiment folder. You have your vocab. Here, vocab size is 100. You can obviously try with the various parameters that were defined in the configuration file. So you primarily define your architecture in the configuration files and run it through the run.sh. If you're trying newer architectures or you want to try transformer elements, you define that in your configuration file and use that. And we then just here now, after finishing the training, we are computing the perplexity on the test data set, and we have got a good perplexity on this, approximately 13.91. That's just to guarantee that the parameters that we have given for the language model are correct, and we don't need to further worry about it. So we can just do a small test of the language model individually by computing its perplexity. That's there in the log file. We can see that gets generated. So while you're training your systems, and if you don't get a good perplexity, you need to understand that something is wrong in the data or in the LM configuration file that you have provided. Now we come to the training of the acoustic model. For training the acoustic model, again, we define the architecture of how many decoder layers or the encoder layer, what type of, how many attentions you need to do, or what should be the weight of the CTC in the configuration file. And the details of what each parameters means, you can find that in the ASP.NET documentation. Here we have defined a few set of default parameters for to have a quick acoustic model, and then we start training the acoustic model by providing it a single GPU. And the stage 4 is acoustic model training, and this will take some time to run. You will get a log file which will show all the loss functions that are there at each epoch. You can see how the model is training. It also generates some plots for you to monitor the training. Then after training, we come up with a decoding where we are doing CTC based beam search based decoding over here, and we just identify certain parameters on how much should be the beam side, how much weight you want to give to the language model, etc. and we run the decoding. And after the decoding, here we have our word error rate computed itself on the test data. So here the word error rate that we have got is about 8.8, and that's how we are decoding it. And you can plug in your own data over here. You have record wave.sh as another script which you can use if you want to use this model to transcribe a particular wave file of yours. So I have not run the scripts, but this collab notebook is available on Drive, and I'll be sharing the link along with the video. So all of you can try this. And besides this, there's several other notebooks in ASP.NET Toolkit as well for you to get started. I hope you all can, with the help of today's session, you all will be able to train simple end-to-end ASR in ASP.NET, or and have your own transcriptions of certain wave files or recognize certain wave files. Thank you.
Thank you, ma'am. That was very kind of you to take time from your busy schedule and giving us a talk that was lot informative, and indeed, and it was a very interesting topic too. I just hope that everyone who is out there has enjoyed and even learned everything about what you have said. Thank you, ma'am. So I would like to introduce the next speaker for today. That is Neha Mittal ma'am. She is DSP engineer at Cavo, and the topic she is going to talk about is OCR Tesseract model versus deep learning model.
Hello everybody, good evening. Today I'm going to talk about OCR and compare Tesseract with deep learning models used to do the same. So let me start by introducing myself. I'm Neha Mittal and I currently work at a startup, Cavo, in Bangalore. I spent most of my career working with startups. I did my master's in signal processing and have worked in the areas of audio and image processing. I have applied the so-called traditional ways of image processing in solving most of the problems. Few years back, I delved into deep learning, and since then, I have been learning more and more in the same. Let's define what OCR is. OCR is nothing but digitalization of printed text. Broadly speaking, OCR has two steps involved. First is text detection, which is finding out the text areas in a given image, and the other is text recognition, which is passing on this recognized text to a database and to find out what alphabets or what text is actually over there. So the text detection the output of text detection is usually a bounding boxes around the text. Applications of OCR are intuitive enough. So reading documents, prescriptions, bills are general applications of OCR. Then with all the processing power sitting in our phones today, a lot of interesting applications have come out of it. These are this kind of OCR is termed as OCR in the wild. So let's assume you're in a foreign land and you are if you don't understand what's written on a signboard or a food menu, so you just pull out your phone and take an image, and in the background and the text gets translated into your native language. So in the background there are multiple step process, right? First is OCR on the foreign language. That is that text read through OCR is passed on to a translation engine. Again, these days it's very common that from an image you extract a phone number and then you dial it. All of that is OCR. Tesseract is an open source API, and it is currently maintained and developed by Google. It is it It is the latest and greatest code. It's not outdated. You can use it out of the box. There are a lot of pre-trained dictionaries available for different languages. So a lot of work has gone in building Tesseract, and it works perfectly. So yeah, so there are some boundaries to the perfectly, but yes, it's a good tool to work with. One thing I would emphasize on here is it's because the entire C++ code is available. You can actually build it for any platform. If so, like embedded kind of use case, Tesseract is a good deal. Yeah, it has the cross. You can cross compiler it. You can cross compile it. It has it uses CMake right now. This the entire code. So how it works? You'll first read the image. Usually read image through OpenCV, pre-process it. If your image contains a lot of graphics, so there could be two kinds of images that you want to perform OCR on. If it is like a document, like plain text, you can just pass it on directly to Tesseract. If it has graphics also, then it would give better results if you extract out the text from it, like crop just the text from it and then pass that on. Get UTF-8 text is the Tesseract API, which gets called, and the result is your UTF-8 text. If you look at this diagram over here, I've also mentioned the paper. You can refer to it for further details. But these are the basic building blocks of the Tesseract engine. The input image is fed to an adaptive thresholding unit, and the output is a binary image. This is then fed to the connected component analysis unit. The picture over here on the right is the output, is the binary image. Connected component analysis then extracts the character outlines. These outlines are converted to blobs. Blobs are organized into text lines. Text lines is nothing but words, and lines and regions are analyzed for fixed pitch or proportional text. Text lines are broken into words. Text is chopped by character cells. So we get bounding box around each character, like this. So that brings us to this. And then recognition here is a two-step. Recognition is a two-step process. First, this segmented text is classified to extract text from the image. And the pass-to of the recognizer is used to know the context of the image. Your context of the image is basically the font name, font size, things like that. So that is predicted and is used for better OCR detection. So if you're reading plain documents, Tesseract is the best out-of-the-box solution available. Now let's look at some of the challenges. Low resolution images are a problem. Background has to be plain or synchronous for Tesseract to work well. So if you have a document in which the background is not plain white, if the text is black, of course, and there is a big logo behind. So areas where the logo is visible, Tesseract might pose problems in those areas. Yeah, so these are some of the problems. I'll show you a small example of Tesseract. What you see on the left is text that I passed on to Tesseract. Like you can see, the font size is changing after every sentence. This is the output. Um, this is the output of Tesseract. Now here only um, one character was wrong, read incorrectly. I. What I did next was I reduced the resolution of the input image, and this is the output. Here, if you see, please, one L is missing, and this, right? This was supposed to be heart is. So it missed some words and it could not identify the spacing. Also, what is more interesting to notice is this smallest size text. It's all messed up over here. So this is one of the challenges of OCR or Tesseract, basically. Now let's move on to the deep learning model. So I'm going to talk about the model that I used for doing OCR. There are some of the applications that are better addressed by deep learning: handwritten text, OCR in the wild, CAPTCHA, license. There are open data sets available for most of them. MNIST is being the oldest, and now it's so old that it's become like the hello world problem for AI. For text detection, I used EAST, and for recognition, use this model called as CRNN. I'll just talk about that. So this is EAST. The network is a fully convolutional network. There is a pre-trained OpenCV model available which has been trained on scene text dataset. This dataset consists of images in different settings and lighting conditions. The model that you can see here in the picture can be decomposed into three parts: feature extractor stem, feature merging branch, and the output layer. The geometry output can be either R-box or a quad. For R-box, the geometry is represented by 4 channels, AABB format, along with a rotation angle. This box output then goes through NMS, which is non-max separation. One variant of NMS which works better here is the locality aware NMS. CRNN is convolutional recurrent neural network. It consists of 3 components: convolutional layer, recurrent layer, and transcription layer. So convolutional layer and recurrent layer are intuitive enough. Transcription layer is used to translate the per frame predictions for the recurrent layer into a label sequence. So though it consists of different kinds of network architectures, it can be jointly trained with one single loss function, which is the CTC loss. I'll show you some examples again. So this image I passed through, this is the output of Tesseract. So like you can see, the first and the last line of the text got read perfectly. The problem was with the middle graphic portion of the text, right? Marvel Iron Fist, it did not get read. Because it's intuitive enough, Tesseract doesn't have, is not trained for this kind of font. So here we jump into using deep learning. This is the output of EAST on the same image. If you see here, this A did not get detected. Right, this A got missed out. Otherwise, everything else was, all the other words were detected properly. This is a low resolution image. Like you can notice, the first line did not get detected at all. Now here, what you see is there is a single box around Marvel and Daredevil. This is not the problem of detecting the text, it is more of the problem of NMS, which is the non-max suppression. So when we did non-max suppression on these two, the two bounding boxes got merged. This is because I've used the traditional non-max suppression over here. This image, everything got detected except the main title of the image. This did not get detected, the title. So like you can see, even deep learning models have their flaws and challenges. Most of the demos that we see available online or articles we read just show you the rosy picture of using any out-of-the-box solution. So just try to jot down some of the challenges, but I think that's clear from the examples. That should be clear from the examples I showed. So look at the application and think, can it suffice by Tesseract? Because it is an age-old thing, and plain text like given fonts and everything, it works perfectly well. Let me just summarize the comparison between the two. So Tesseract is well or better used for documents. Even if you have text at fixed positions in an image, Tesseract is your bet. And deep learning should be used for reading text in the wild and signboard kind of things. You might have to train your own images, right? You just using the available data sets might not suffice. So one of the models that I used for um, my text detection, which I just demonstrated, it's trained on the scene text database, like I mentioned. So the challenge there was that it is only trained on alphabets and numbers. So if I needed to read something like special characters, it would not work. So you don't need to append it with your own data set and transfer on further. This I did not mention yet, that Tesseract needs low processing power, so CPUs are enough for the processing. Whereas deep learning models, if you need to run them fast, you do need GPUs and TPUs. There's a lot of pre-trained models already available for Tesseract, so most likely you do not need to train your own data set. However, the process of training does appear to be a little cumbersome. It's not as straightforward as we do in deep learning. So in deep learning, you can just, whereas in deep learning models, there is very limited data sets that are available right now. These are the references that I've used for this presentation. In case you're interested in reading the papers and all, do take a snapshot here. So that brings to the end of the presentation. This is all I have time for. Feel free to connect with me. That's my email ID. You can use the QR code to get more details. My social media handle, most of the places, is Mithil Neha. I am looking forward and looking to connect with like-minded people who work in the area of computer vision. I am very passionate of continuing to work in this area. Even if you have any problems or like need to discuss something, please feel free to connect back. I would also like to take this opportunity to thank WIDS organizers. You guys are putting together a very nice, very nice set of presentations, and it's helpful to all of us. So thank you.
Thank you, ma'am. That was really a knowledgeable session. We would like to thank you on behalf of WIDS, sir. And now I would like to call upon Nitya, my co-anchor.
Thank you so much, Ganya. Now, the fourth speaker for the day is Ms. Janvi Patel. She's a data scientist at Elegant Microweb, and she's going to be talking on anomaly detection and fraud transactions. Over to you, ma'am.
So first of all, thank you so much, Nitya, for your kind introduction. And I would like to thank Usha for organizing Women in Data Science community and giving me the opportunity to talk about anomaly detection in fraud transaction. So as we all know that credit card company collects our data on daily basis of everything we purchase, even including the amount of money we spend, where we spent it, even the product we are buying, and how frequently we make some transaction. So there are some high chances to be caught by frauds and which are likely to occur when we are in the digital India making effort. So it is very concerned topic of many business users to how to protect their company from fraudulent activities. So this motivated me to pick up this topic. So anomaly detection, we'll first look at how we can find anomalies. So first questions comes up in everyone's mind is what is anomaly? So data points that deviates from what is standard, normal and expected within a group. That point is anomaly, which is different from other points. Say in this image, there is a red egg, which is different from the other eggs. That is anomaly. So anomaly detection is very useful when we are dealing with credit card fraud transaction. It will identify fraud in the fewer seconds, and it will try to avoid some kind of fraud prevention. So by the definition of anomaly detection, we might have some question like, is it not just classification? Because by definition, it looks like it's for classification, we just need label data in which we have some like normal class and the anomaly points. So is it not like just classification? So the answer is yes, if three conditions are met. First is you have label training data set, but in our case of fraud transaction, we might not have label data set because fraud detective person will not give a label which is a fraud transaction and a normal transaction. So that would be unlabeled data or let's say semi-labeled data. And second is anomalous and normal class are balanced. So in real time, the data would not be balanced data. So specific for this case, we'll be having lots of imbalanced data set. Say we'll be having 2 or 3 anomalies for thousands of records only. So that would be highly imbalanced. And third is the data is not autocorrelated. So autocorrelated is one that one point is depend on the other previous points. So this might be a case when we have autocorrelated data in time series analysis. Or let's say we give example of IoT cases in which we have sensor data. So that would be highly autocorrelated data. Next is types of anomalies. So there are basically 3 types of anomalies: point anomalies, contextual anomalies, and collective anomalies. For point anomalies, we have a single instance of data which is anomalous if it is very far from our normal data set. So by this image, we can see that these are the highlighted points are anomaly, which is the higher voltage, or some points here are very lower voltage. So our fraud detection case will be lied into point anomalies. Second is contextual anomalies. So it is specified by contextual specifically, and it can be seen in time series generally. So let me give an example of let's say we are buying sweets on festive season, let's say in Diwali. So there will be a higher sale in the duration of Diwali occurred, and not in the normal days. So people not are buying sweets in the normal days. The third is collective data set. It collectively identifies the anomaly. Let's say if one person is trying to copy the data from remote to the local machine, which is common nowadays because we are working remotely, right? So in that case, if some cyber attack happened to you and we suddenly stopped copying our data set, so that are these points which is highlighted by red points. So that is collectively anomalies. So why anomaly detection for credit card fraud identification is so useful? So this is there is a significant increase in usage of credit cards compared to the previous years, and we have some kind of benefits from using credit cards, and on the other side we have some losses and we faces some frauds by using credit cards, and that there could be millions of frauds are happening nowadays. So anomaly detection will try to identify whether the transaction has unusual patterns, say by giving time and looking at the amount which we are spending. So we can also have some method to just prevent our fraud, and we can also set some conditions from the owner of the bank account to just have some approval before doing the transaction. So this might be useful for that cases. So basically, the use case which I am talking about includes modeling past credit card transaction with the knowledge of the ones that turns out to be fraud. So basically, it is a label data set, and credit card fraud detection data set contains made of the data set by European card holders, and the data set is collected within 2 days only, and it has 492 fraud records out of 284,000 transactions, which is highly imbalanced data set, and it has, I think, 0.17% of the fraud which is labeled as one class in our data set, so which is very less. The data set has been pre-processed, and we have given PCA transform data to out of security. The data set is lagged with some background information of features and also about the details of credit card holders and what are these factors. So we have just calculated the PCs for every features. So by this image we can look at that we have numeric data of V1 to V8, which are pieces from principal component analysis, and we have time as a feature, which is nothing but the time which the seconds elapsed between each transaction, and the amount, which is the transaction amount, and we have target as a class. So in target class we have we have two classes. One is for fraud transaction, and 0 is for the normal transactions. So these are the details about data sets. So yeah, I have taken only sample data set to compute this outcome. So let's say I've used isolation forest and local outlier factor to identify anomalies in this data. So you guys might have heard about anomalies algorithms like one class SVM, K nearest neighbor, and so many deep learning algorithms also. But I have used these algorithms for the purpose of imbalanced data set. To compute is very easier. Computationally, it is very faster to have isolation forest and local outlier factor, and it contains very less memory. So let's say in general, the first step to identify anomaly is when we are looking at the normal anomaly detection algorithm. They construct a profile for what is normal first, and then report anything that to be considered as not normal, which is anomalous. But this isolation forest algorithm is basically work on the principle of not defining normal behavior first. It also not based on the calculated point-based distances. As you might expect from the name, isolation forest is instead works by isolating anomalies explicitly in the data set. So it basically uses the principle that anomalies observed are very few and very different from which are the normal points. So it is very easier to identify them for these are the outliers. So it uses basically the ensemble of decision trees, which you can see from the image. And so how does it work? So it generates the partition of data set, randomly selecting a feature and then selecting a value for split, which is called as a score for a particular value of a point. So presumably, I think that anomalies need fewer random partition to be isolated compared to normal anomalies. So what does that mean? So anomalies will be the points which contains smaller paths length to the tree. So in this example, we can see that outliers are easier to isolate it. These are the outliers and these are the inliers, which is the normal points. And the other algorithm is local outlier identification. Local outlier factor is the algorithm so identify outlier which computes the local density deviation for a given data set with respect to its neighbors. So it considers as outlier sample that have very low density. So here we can see that we have a huge amount of data here. So it is the normal points and these are the two outliers. So this algorithm can be used for unsupervised learning algorithm, which I have mentioned earlier, that will be not having labeled data for fraud detection in real life scenario. So for that, we'll be using this. So as a result, I will be comparing these two algorithms. So I have applied credit card fraud detection algorithm on fraud detection data set on isolation forest and as well as local outlier factors. So as a result, isolation forest gives 73 errors and local outlier factor gives 97 errors, which is higher. When we compare accuracy score for both the algorithms, which is almost around the same, which is 99%. But the classification reports differs a lot. So in isolation forest case, we can find that recall for fraud detection is 97, which means 97% of data is correctly identified as a fraud, which was originally as a fraud in the data set. But in the local outlier factor, we can see that we have only 2% of recall, which means that we have not correctly identified the data points. We have also some mismatch in the frauds and the normal points. So by this observation, we can say that isolation forest is best useful for this particular use case. And we can also increase our accuracy and recall by increasing our sample size of data, let's say. And even we can also try some other machine learning algorithms. And also deep learning, we can also try deep learning algorithm, but it will cost computationally very higher compared to the machine learning algorithm. So I would like to talk about related topics to anomaly. So in my job place, I'm working with anomaly detection and trying to find some generalized algorithm for any of the cases, regardless of what data I will be given or what kind of size of will be the data, and anything like it will be unlabeled data or labeled data. I'm trying to identify some conditions to figure out anomaly easily. So I'm looking forward to like two different questions, like how can we identify reasons for anomaly? So these are the most concerned about business users. So let me give an example to give answer to this question. Let's say example of sales data in which we have gross sales as our target, and we'll be having city, state, as well as say product category, product name, and discount given or not as our predictors. So in that case, when we are looking for reasons, we will be finding anomalies first, right? So that anomaly can be a profitable anomaly or non-profitable anomaly based on the gross sales. So when we are filtering the anomalies, we'll be suppose we'll be having some gross sale which is the highest gross sale of the year. So a business user would like to identify what will be the reason for it. So it might be the reason that we have given we have given 20% discount on let's say product laptop in Ahmedabad city. So that is the reason why we are having gross sale as highest in the era. And the second question, which almost all business users are concerned of, is in business use case, anomaly detection can provide profit also. So how can we use anomaly detection to gain profit? So let's say continuation with the previous example of sales data, we can generalize that suppose in the South India there is a highest sale of rice, and it is giving me the highest amount of gross sales. So I'll be directly increase the production over there. So it will lead me to the profit. Even I can also find out the trends of anomalies. Suppose using anomalies, I can also give that in the month of March, you have decreased your profit. So what could be the reason for it? So we can also use this kind of algorithms to even help business users to gain more profit in their domain. Please do that. Let me know if you have any ideas about how we can analyze our anomaly detected points to gain profit for business users and generalize it. I'll be love to hear the things about and the ideas about from you. These are the references in case if you want to look at any point of time about the topic. So that's all. Thank you so much for being such a wonderful audience. And if you have any questions or any suggestions for me about this topic or any other topic in data science domain, let's connect on LinkedIn and Twitter. This is the my profile. And stay healthy, stay safe. Thank you. Bye-bye.
Thank you so much, ma'am. That was a very amazing talk, and especially about the credit card frauds and everything. That's something that we deal with on a daily basis, and we're probably going to deal a lot more in the coming years. So thank you so much. That was an absolutely amazing session.
Thank you, Vidya.
Thank you. Ganya, can you please introduce the next speaker?
Yes, Nitya. The next speaker for the event will be Sanoba K. Khan. He's a senior software engineer at Cloud Assert, and the topic he is going to speak about today is IoT and stream analytics in Azure.
Hello everyone, good evening. Welcome to another episode of Women in Data Science Mysuru chapter. I am Sanobar Khalifullah Khan. Today I will be talking about IoT and Azure Stream Analytics. So before we get on into this session, I would like to extend my gratitude to Usha, who has given me this opportunity to be a part of this session. Thank you, Usha. This is today's agenda. Firstly, I will give a brief about myself. Then we will look into IoT edge devices, IoT and cloud, components of IoT, Azure IoT, communication between IoT and cloud, Azure IoT backend services, real-time analytics with ingested data, Azure IoT Edge, Azure Stream Analytics, and real-time analytics on geospatial data. I am Sanobar Khalifullah Khan. I am a certified public cloud expert offering solutions to humankind on top of hybrid cloud. I have diverse industry experience in developing solutions on cloud platform. I offer solutions to clients across the globe in domains like banking and financial services, micro-market clients, large IT clients, government services, and food delivery clients. Let us now. I am also a Gold Star Award winner offered by Cloud Asset for delighting customers. I am also recognized for the following leadership qualities of customer delight, customer obsession, earn trust of others, deliver results, ownership, accountable, and result-oriented. Now, let us get into our session. IoT Edge Device. What do you think is an IoT Edge device? Any device that is connected to internet is an IoT Edge device. The Internet of Things is reshaping the way we live and work today. Whether we are changing the temperature of a thermostat at home or waiting at an IoT-enabled traffic light, connected sensors and the data they generate gives a set of new experiences that were never even thought of a decade ago. IoT data can be gathered from multiple devices, and this data can be stored and consistently used to predict future, prevent maintenance issues, thus reducing cost, improve worker safety, reducing revenue loss due to product defects, even saving lives. There are a number of examples for an IoT device. I have listed 2 examples here. A temperature sensor installed in a building is an IoT edge device. IoT-enabled camera system within a building to identify people in the family is also a IoT-enabled device. Let us look into IoT and cloud. IoT edge devices brings cloud capabilities directly to the users and devices that need them. We can best harness the capabilities of IoT system together with cloud computing. IoT systems together with cloud computing brings easy, rapid scaling, high volume data storage, machine learning to identify critical patterns in the data. Now let us look into the components of IoT. IoT edge devices are finally bringing cloud capabilities directly to the users and devices that need them. So here are the 5 components of IoT edge computing. First comes the complex event processing. Next, we have machine learning and artificial intelligence models. Next, the applications which run either on cloud or on the edge device. offline support, and data management. Let us now look into these components in detail. A complex event processing system takes in data from multiple sensors or signals and then acts on the data as specific pattern arises. Machine learning and artificial intelligence. The core idea behind machine learning is to enable a machine to learn the significance of data. These models can be built using known algorithms, while more advanced machine learning tools focus on training the computer to learn patterns and anomalies so that it can then learn on its own. Applications. Some of the most powerful IoT edge devices have introduced the ability to run applications directly on the edge device. Most of these platforms have been designed to support containerized applications, allowing specialized apps and services to be delivered directly to the device. Offline management. Many IoT devices, the network connection suffers from constrained availability. So in these cases, the IoT devices include storage options to hold data temporarily until a connection is restored. Data management. The final element of the core IoT edge device is data management, knowing which data to keep and which to discard because it has little business value. Azure IoT. The Azure IoT is a collection of Microsoft-managed cloud services that connect, monitor, control billions of IoT devices. In simple terms, an IoT solution is made up of one or more IoT devices that communicate with one or more back-end services hosted in the cloud. So let us look into how this communication happens between the IoT device and the cloud. It is usually a two-way communication, device to cloud and cloud to device communication. For example, a device monitoring a batch reactor in a chemical plant sends an alert when the temperature exceeds a certain value. Now let us look into IoT backend services offered by Azure. So there are quite a few backend services, and so here is a list. The first comes receiving telemetry from devices to determine how to process data and to store data. Analyzing the telemetry to provide insights, real-time insights or any insights which will help making a future decision. And then sending commands from the cloud to a specific device. And then we have provisioning devices and controlling which device can connect to your infrastructure, controlling the state of the device and monitoring their activities. And then we have managing the firmware installed on any device. So these services, with the help of Azure backend services, anything can be done directly in the edge device. Now let's look into Azure IoT Hub. IoT Hub is a managed service hosted in the cloud that acts as a central message hub for bidirectional communication between the IoT application and the device it manages. We can use Azure IoT Hub to build IoT solutions with reliable and secure communication between millions of IoT devices. We can also integrate the IoT Hub with the Azure services to build complete end-to-end solutions. For example, these are the following are the Azure services which we can use to build end-to-end IoT solutions. The first comes Azure Event Grid. Next, we have Azure Logic Apps, Azure Machine Learning, and Azure Stream Analytics. Azure Event Grid enables businesses to react quickly to critical events in a reliable, scalable, and secure manner. As Azure Logic Apps is used to automate business processes, Azure Machine Learning is to add machine learning and AI models to IoT solutions. Azure Stream Analytics is used to run real-time analytics computation on data streaming from the IoT devices. So let us now look into the architecture of real-time analysis of ingested data. We have a set of IoT devices. So these devices will send the input to the IoT through the IoT gateway to the cloud gateway into the cloud. So this input stream of data, it can be received either by an IoT hub or an event hub, or it can be passed to an Azure Stream Analytics job or to a IoT hub route. So this data, which is received by an event hub, can be sent to an Azure function app, and this function app will decide what has to be done with that data, and later it can be processed and saved into a Cosmos DB or any other storage account. The input stream of data, which is passed to the Azure Stream Analytics job, will give an output based on the requirements of the analytics. And this output, which comes from the Azure Stream Analytics job, can be sent to a function app, or it can be sent to a Azure Logic app. Now, the input which is sent to a Azure Hub route can be sent to a Azure Storage or Azure ML. So usually, the Azure ML and Azure Storage are used for training and machine learning purposes. So next comes IoT Edge or Azure IoT Edge. The technology that utilizes edge compute is called Azure IoT Edge. It can run cloud workloads, artificial intelligence, Azure, and third-party services directly on the edge device. And we can also include the business logic on the IoT edge device. These IoT edge devices react more quickly and operate reliably even in extended offline periods. Now let us look into Azure Stream Analytics. Azure Stream Analytics is a real-time analytics and complex event processing engine that is designed to analyze and process high volumes of fast streaming data from multiple sources simultaneously. It uses simple SQL-based query language. It can process millions of events every second. It can deliver results with ultra-low latencies. So one such example is geospatial analytics for fleet management and driverless vehicles. So let us look into the architecture of the Azure Stream Analytics job. So we have three parts here. The first part is ingestion, from where the data is inputted to ASA job. The second part is where the analysis happens, and third is the output of the analysis. So the input which is sent to Azure Stream Analytics job can be an input from IoT devices. It can be an input from log files. It can be an input from a bank transaction or any other transaction. It can be an input from weather data and also an input from any application. So these inputs are sent to Event Hub or a blob storage or a IoT hub. So the events which pass through the Event Hub or the blob storage or the IoT hub are then queued in such a way that these Azure Stream Analytics jobs can pick up the data from the queued input stream, and they can process the data to produce outputs. So these outputs can be alerts, or these outputs can be displayed on dashboards such as Power BI. These outputs can be stored in data warehouses, or it can be archived for machine learning purposes. We can harness robust analytics with simple SQL. So the Azure Stream Analytics job uses data manipulation statements, just like how we have in SQL queries. We have a bunch of aggregate functions. We have date and time functions. We have temporal functions like lag, is first, last, collector. We have scaling extensions. We have string functions, and then we have window extensions and geospatial functions, and at the end we have mathematical functions as well. So let us look at some sample queries. A very simple query with just input stream to output looks like select start into output from input. Means whatever is the input is from a device is as such sent to output. So now let's look at another sample query with string matching with like and not like. So here is the query. Select star from input, timestamp by time, where license plate like 8%9. So this will output all the cars or the input will be filtered based on the license plate, like the matching string. Now, let us look at another example to fetch past events within a time window and compare them against the current event. So here we use the lag function to look into the past window, and then we limit the duration to 1 minute to compare it with the current window. Now let us look into stream analytics windowing functions. So the stream analytics windowing functions are used to perform analytics on data contained in temporal windows. A temporal window is nothing but a particular time period. There are 4 kinds of temporal windows: tumbling window, hopping window, sliding window, and session window. So let's look into each of these windows. A tumbling window. So the tumbling window can be best explained with the help of the query, which I've used as an example. This is a query to get number of active Uber cars per time zone every 5 minutes. So I have a tumbling window of 5 minutes here. So every 5 minutes, this query will get a number of active cars per time zone. So this query will be executed for every 5 minutes to check how many cars are active per time zone. So a tumbling window gives output based on the window period. So next we have hopping window. Hopping window can be best explained using this example. So I have a query here that gets the number of lightnings every 5 minutes over a period of 10 minutes. So the hopping window period is 10 minutes with a 5-minute hop. Means every 10 minutes, this query will generate a result which gets the number of lightnings that happened every 5 minutes. So next we have a sliding window. A sliding window can be best explained using this example that gets the average wait time for all patients currently in the waiting room. A sliding window outputs events only for points in time when the content of the window changes. In other words, when an event enters or exits the window. So for example, here the sliding window period is a 10-minute window period, but in the 11th minute we have a new patient coming in, so the sliding window changes, and this query will get executed as part of the Azure Stream Analytics job, and a new output will be generated. Now, in the 15th minute, if a new patient enters, then again the sliding window is different, and the query will be executed, and we get a new output. So this is what is sliding window. So this is a session window. Session window can be best explained using the example query here. This query is to measure how long user sessions are. So this query uses user ID as input and minimum time as the window start time and current time as the window end time. So the difference between the minimum time and the current time gives the duration in seconds, which is nothing but a user's session. So this query can be used to find the user sessions for Facebook, Instagram, etc. So next we have real-time analytics on geospatial data. Geospatial functions in Azure Stream Analytics enable real-time analytics on streaming geospatial data. So where can we use this? The use cases, the real-time use cases are countless, and I have just mentioned a few real-time use cases here, like ride sharing, personal tracking, fleet management, race car telemetry, asset tracking, connected manufacturing, geofencing, facility management, phone tracking, swarm robo management, etc. There are 7 built-in geospatial functions in Azure Stream Analytics, and those are create line string, create point, create polygon, ST distance, ST overlaps, ST intersect, and ST within. So create line string is a function which takes latitude and longitude as input, and it creates a line in a particular region. Create point takes latitude and longitude as input, and it creates a point. Create polygon again takes the input, and it creates a polygon in a particular area. ST distance is a function which calculates the distance between 2 points. ST overlaps is a function which figures out whether 2 polygons overlap with each other or not. ST intersect is a function which figures out whether 2 lines intersect with each other or not. ST within is a function which figures out whether a point or a polygon is within another polygon or not. So as I've mentioned, there are n number of real-time use cases. I have just brought in one here. With the help of geospatial data, we can figure out human mobility in a particular area. This human mobility data can be used to uncover human behavior to track and control COVID-19. It can be used to figure out concentration of vehicles to divert traffic. It can be used to position billboards at the right locations. And the sources of human mobility data are GPS data, cell tower data, Wi-Fi data, etc. So with this, we have come to an end of our session. I hope you enjoyed the session. These are the references I used, and I hope these would be useful to you as well. And here are my contact details. You can mail me at sanobarkhalifullah or sanobarkkhan@gmail.com. And this is my LinkedIn site. You can visit my LinkedIn site at www.linkedin.com/n/sanobarkkhan. And the queries which I used in this presentation are available here in this link, which you can use it for your reference. So thank you for being with me. I hope you enjoyed the session, and I hope you are enjoying the other sessions as well. Bye-bye.
Thank you, ma'am. That was very informative and a good session. Thank you, ma'am.
So now we have Miss Henna Konya, who is an associate data scientist at Ecolab, and she will be talking about hyperparameter tuning Dusk. Thank you so much, ma'am, for being with us.
Thank you so much. I'll just be sharing my screen.
Yes, ma'am.
Yeah. So hello everyone. As given introduction, I am Hina, and I work as associate data scientist at Ecolab. My work primarily involves around Python and SQL. So today we'll be talking about hyperparameter tuning using Dask. So Dask is a library which is used for scalable machine learning. It's a lightweight library used for exploring data and model selection, which is also built for task scheduling for higher computation. So the agenda would be, we'll be discussing about what's hyperparameter tuning, its current state of art, and scaling hyperparameter searches, which involves adaptive hyperparameter optimization using Dask ML library. So what is hyperparameter tuning? A hyperparameter is a free parameter which is not learned from data, which defines how well our model trains. So the process primarily involves of data pre-processing. Then we do data splitting, that is into train and test data. Then we choose hyperparameter for a particular model, or we build a pipeline, and then we score the model on validation set. So we get the best score, and we choose the best hyperparameter to train on whole complete data. So the current state of art involves two types of algorithm which is widely used. One is passive algorithm, which does not involve information from previously trained configuration to inform that which hyperparameter should be trained next. So those are randomized search CV and grid search CV by sklearn. And the other is adaptive algorithm, where we use information from previously trained configuration to decide which hyperparameter to choose next. And this involves Bayesian searches, which includes some techniques like sequential model based optimization, tree structure parse and estimator, and spearmint from AutoML. So to parallelize this operation, since it would be hard to refer to each and every hyperparameter, and it would also be a time consuming process. So to parallelize this operation, it's easy for randomized search and grid search, because those hyperparameters are independent of each other. The set of hyperparameters are independent of each other. So we can scale to any number of machine. Whereas for adaptive search algorithm, we avoid extra computation and we find high performing hyperparameters quickly by deciding on the previous information it was trained. So it is difficult to parallelize and scale because it's a serial computation. Now, when we have a large data, or we have large number of compute, that is large number of set of hyperparameters, it takes time consuming. Also, it would be in two problems, that is memory constraint or compute constraint. So memory constraint occurs when we have data size is too large and it does not fit into memory, and compute constraint occurs when it fits into memory but it takes too long to train it. So four combinations are possible, that we neither have compute constraint or memory constraint. So then we can use grid search or randomized search CV, which is by scikit-learn. But when we have compute constraint but not memory constraint, or vice versa, that is memory constraint and not compute constraint, grid search CV or randomized search CV might not be much helpful. Same case will occur for memory and compute constraint. So Dask ML also has parallelized random search CV and grid search CV, which avoids repeated work. So it performs as this. So let's consider we have a pipeline where we have three parameters. That is, we have a count vectorizer, we have a transformer, and then we have a classifier. And for them, we have particular grid. Now, primarily, what scikit-learn grid search would do is if we parallelize those all operations, then it will run through whole data with considering with each combinations. Whereas what Dask ML grid search would do is it would avoid repeated work. That is, once the count vectorizer or transformation is done, it will not repeat the same action again. And this would take less time to choose the best hyperparameter. The other algorithm we'll be talking about is adaptive hyperparameter optimization, which is provided by Dask ML. It primarily uses principal early stopping scheme in its adaptive search, and they have three, that is hyperband search CV, successive halving search, and inverse decay search. Moving to successive halving, so it is based on non-stochastic multi-amp bandit algorithm. So at an overview level, how it works is, so at a base, we have, consider it as we have 8 hyperparameters, possible combinations. So then we'll train set of estimators for certain number of partial fit calls for each possible combination. What is partial fit calls? It is based on mini batch sample. So each hyperparameter will not be training on whole data. It will be training on some amount of data. So once we have training done on each configuration for a certain amount of partial fit calls, we'll evaluate all those and we'll promote only top half performing set. That is, we had 8 and then we'll promote the best performing 4 out of them for twice the time. So for example, for initially we took k time, and for the next iteration it will be twice the k times. This process would repeat until we are left with a one set of hyperparameter which will run through whole data. Now, successive halving by DAS-ML, it generalizes by parameter called aggressiveness. So what aggressiveness is, it's a number that we provided. So for example, we provide a 4 value, then it will divide every moving surviving estimator by the number of aggressiveness. So for example, we have 16 set of hyperparameters which will be fitting into partial fit calls. So again, we'll be evaluating its performance on all set of parameters, and then we'll be only promoting 16 divided by 4. That was our aggressiveness, which we will remain with 4 set of hyperparameters, which will be training for 4 times the previous iteration. This process will repeat until we are left with just one parameter or one set of parameters. Now, hyperband, we're moving into hyperband search, how it is different from our previous successive halving search. So it involves around the same concept. It speeds up the random search through adaptive resource allocation and early stopping. But here, early stopping is done with a different technique. So it involves around 2 extremes. That is, we have only training data which is important, or only hyperparameters are mattering. So what hyperband search does is it balances between these 2 conditions to frequently stop training, and it finds the best model with minimal partial fit calls. The other is inverse decay search. So this also is similar to the previous 2, but the early stopping scheme is different, where we initially start with a training on small amount of data with given set of estimators, but at every kth time it will retain only 1 divided by k plus 1 fraction of highest performing set of estimators, and this parameter is inputted through decay rate in it. So higher the decay rate, we'll have in less time we'll able to get our set of parameters, but it will lose some of its good performing hyperparameters as well. Now looking at some example, so I created a DAS cluster on my local machine, and which had 4 cores and 4 worker, and to test each of the 3 how it works. So we created a synthetically data where we split into train and test, where our train size is 25,000 cross 6 column and test is 5,000 cross 6 column. Now here the parameter search, that is successive halving or hyperband search CV or inverse decay, it requires more number of parameters compared to our scikit-learn grid search or randomized search. So we'll be looking at some of the parameters which it requires. So one of them is max iteration, that is how many times it will be doing partial fit calls on every chunk of data. So what we do is, let's say suppose we have a X train of data and we divide it into chunks by number of examples and the number of parameters we want to have in each call. So on right figure, you can see that we have two chunks each of 12,500 shape, and we have two tasks to be done. Now this each chunk will be trained on each partial fit call. So let's take an example that we have a MLP classifier where we have a 4 set of parameters, and comparing each of them on local DAS cluster. So for hyperband search CV, we input max iteration, and when patience equals to true, we apply it when we don't want to, when we want to stop early, when the tolerance is, when it's not increasing the tolerance. So similarly, for successive halving, we have parameters that is n and r. So r is nothing but it's a number of parameter setting that are to be sampled. So before scoring, how many times do we want to do partial fit initially, and maximum number of partial fit calls per model, how many it is required. So the time taken for them was highest for successive halving search CV. Also, we found a best score for it. Since it had best score, I scaled it to large data, that is around 1.2 GB. So the data set consisted of numerite tournament. So this is publicly available data, and it's a data science competition where every week the data updates. So we have a cluster of 16 cores and 16 workers, and we have memory around 67 GB. A number of rows were around 5 lakh, and we had possible 288 combinations of hyperparameters. Now what happens is, on my left, you can see that we are running successive halving CV, and it trains in 1 minute and 57 seconds. And on my right, you can see that the Dask API, which divides the workload into different 16 workers. So the summary from the algorithm that we discussed, that it returns the best parameter more quickly with less passes through data and with certainty. PyTorch also has a similar implementation using Scorch. All its examples are available in Dask documentation as well as its GitHub handle. Also, I've linked it in the each slide reference as a reference. Now, the successive halving hyperband and inverse decay search, it supports only those models which implement partial fit, because uh, it it runs for every mini batch that we define. So the algorithm like random forest or other forest algorithm like decision tree won't be able to run in it, because it requires a whole data as to decide its parameter. For instance, max depth. Yeah, so this were some of its limitation and its advantages. If you have any questions or if you have any doubts, you can link me to Gmail, and I have already uploaded the presentation to GitHub repo. Yeah, thank you.
Thank you so much, ma'am. That was a very nice session, and it was very informative and fun at the same time. So, thank you so much for being with us today.
Thank you.
Thank you, ma'am. So now we have Ms. Sita Lakshmi PR. She is a senior program manager with VMware India, heading the Inclusion Tara program. Thank you so much, ma'am. And she was going to be talking on VM Inclusion Tara program. So thank you so much, ma'am, for being with us. Ma'am, can you please switch on your audio? It's actually you've mute your mic.
Is it fine?
Yes, ma'am.
Okay, can you see my screen as well, Nitya?
Yes, ma'am. Absolutely.
Perfect. Thank you so much for that introduction, and good evening and welcome you all for the session this evening. I'm Sita Lakshmi and I am the Senior Program Manager for Women in Tech, handling the VM Inclusion Tara program in India. And I will quickly walk you through what the program is about and how it will benefit somebody in, a quick 20 minutes, of course. So what exactly VM Inclusion Tara is and where does this all begin? So the program is a unique upskilling program by VMware, which will upskill at least 15,000 women across 2 years on VMware technical courses that we have to offer. And this is for women on career break and who would want to return to their careers and want to start a career in IT. Now, I will walk you through the eligibility criteria and how the program has been designed. Before that, a quick glimpse into why this all began was, when we did a survey, we found that nearly 50% of women engineers quit the workforce in the early 8 to 9 years of their career for various reasons like getting married or having a child or taking care of a elderly parent at home. And the reason could be anything, but some of them gather that courage and come back to workforce, whereas many of them get held back, thinking that the technology that I worked on is outdated now, and how will I cope up with what is currently in the market? So that's where the Tara program was born, and VMware went ahead and created this program to help 15,000 women on a career break to come back to work by upskilling them on the latest cloud computing and virtualization technology that VMware has to offer. Moving on, so like I said, VMware and we partnered with Women Who Code to help women in India to return to career in technology. The eligibility criteria is that it's open only to women who are on a career break and shouldn't be on a payroll of any organization for the last 6 months. Can also be a graduate who hasn't been able to secure a job in the last 6 months. Should not be working with any organization. These are the few eligibility criteria that we have. Now, this is not just limited to women who have a technical background. We have opened it up to all, keeping in mind that there are so many out there who have a flavor to start a career in IT and then who can easily grasp the IT concepts and upskill themselves. So we have opened the platform for everyone who is on a career break for the last 6 months. So please make use of this opportunity. The whole program is for free and self-paced, and you can complete it at your own comfort within a stipulated time. I'll just explain the 3 levels that we have charted out. The level 1, VM Inclusion Tara level 1, is a basic course where one will have the complete idea of all the solutions that VMware has to offer under the cloud computing and virtualization solution vertical. So what you do is once you register for the program, of course, if you're eligible, once you register for the program, you go ahead and enroll yourself for the level 1 program, which the course there is VMware Certified Associate for Digital Business Transformation. It's a self-paced 3 hours course. And once you complete the course, you become a VMware Certified Associate for Digital Business Transformation. So what you get once you complete the course is a course completion certificate. Then you get a VMware Certified Associate badge, and you also get a Tara badge. Now, these badges and certificate hold a very good value in the market. So if you are to log on to a LinkedIn profile of VMware, administrator or somebody who has done a VMware course, you can see the visibility that gives that these badges and course completion certificate gives to that person. Now, sorry. So the course, like I mentioned, is for 3 hours. However, what we do is keeping in mind that many of the women on career break are out of touch with these technologies. We do run a live instructor technical webinar where one of our technical instructors go ahead and walk the women who have registered for this course for about 3 to 4 hours. She explains the entire course, and then that will help the women to go ahead and complete these course and understand the concepts easily. Now, once you complete the course and you download your course completion certificate, you get a free exam voucher. With that, you can go ahead and schedule your exam for VCA DBT, which is online again, and you can be a VCA DBT certified person. Level 2 is the intermediate level, wherein we have a vSphere install, configure, manage. So once a person completes this level, she becomes a VMware certified professional. vSphere is our base product, under which on which all the other different solutions like network virtualization, desktop virtualization, or data center virtualization sits on. So it's important that we learn vSphere. The course level consists of 4 components: theory of 20 hours, lab of 20 hours. Then we have the mock assessment and evaluation survey. The course, once registered, is available for a stipulated time of 30 days, and the person can go ahead and complete the course within a stipulated time of 30 days. Now, the whole course is designed in such a way that you can take the theory and lab simultaneously, and we also have online labs chat support, so that in case you get stuck somewhere, we have our associates who can go ahead and help you out with the labs online. Now, once you complete this level, you become a VCP, that's VMware Certified Professional on vSphere, and the exam is the vSphere 6.7 Foundations exam, which acts as a prerequisite for the specialization in level 3 that I'm going to talk. Now, unlike the level 1, where you have to complete your course to get your free voucher for the exam, here, as soon as you register for the level 2, which gets unlocked as soon as you finish your level 1. So as soon as you register for level 2, within a time of about 72 hours, you get your voucher for the exam. Now, these vouchers are exam vouchers are one-time free only. So we urge to go ahead and prepare well and then go ahead and attempt your exam. Once we finish Tara level 2, we are eligible to register for Tara level 3, which is a advanced level or the specialization level. We have 4 different verticals here: data center virtualization, network virtualization, cloud management and automation, and the desktop mobility vertical. So based upon your interest, you can always go ahead and choose one of these verticals, do your specialization here, get your free exam voucher, and then you can go ahead and become a VMware certified professional in that particular vertical. Now, like the Tara level 2, we we have 4 components under level 3 as well, which is our theory for 20 hours, labs for 20 hours, mock assessment, and the evaluation survey. Unless all these 4 components are completed, the courses are not deemed as complete. And once you register, within 72 hours, you get your free exam voucher. Now, to help you choose one of these specialized courses, we also have fundamental courses, which are optional, 3 hours courses each. For example, if you have a confusion between the 4 verticals, which vertical should I go about? What you can do is you can go through these fundamental courses when you reach level 3, which will help you to choose the specialization under the level 3 course. For example, if you want to know what is in data center virtualization, you can choose the data center virtualization fundamentals version 6.5. Go through the course. It will give you an insight into what's available in the data center PCP DCV course. Similarly, for the desktop mobility, you can go through the workforce mobility fundamentals. And for VCP NSXT, you can go through the network virtualization fundamentals, respectively. All these details are available on the website vmware.com/Tara. And if there is any issues, you can always get back to us on the email address that I'll put across towards the end of the slides. Now, so this is the learning path, level 1 to level 3. Once you complete level 1, you get a course completion certificate for digital business transformation. Then you get the VMware Certified Associate badge, and you also get a Tara level 1 badge. Now, foundation level, once you complete, you're eligible for the professional level, which is your vSphere ICM on-demand training, which is, once you complete it, you get a VM inclusion Tara level 2 badge. Now, on the level 3, the advanced level, once you choose your specialization and you complete your course, you get a respective badge for the specialization that you have chosen, and you will also get a combined VMware Certified Professional badge for your level 2 completion as well. So that's the learning path we have for VM inclusion Tara. All this is absolutely for free. The quality of training or the content of the courses are not different from what we offer to our partners and customers at a particular cost. But keeping in mind that the women who are on a career break, it's important for them to upskill themselves, and keeping in mind that these courses, if we put together all the 3 courses, it's $3,000+ for a partner or a customer. But here we are giving it away for free, completely free under the VMware Tara program for women who are on career break. Now, what else do we do to enable the Tara candidates once they register? We have a VMware social channel, which is like a Facebook page for the VMware employees. We extended that up for all the Tara candidates who have registered with us. And we publish all the technical webinars and the briefing webinars that we have, along with the leadership conversations with industry partners. All the details are published on this social channel for the Tara candidates. And we also have the soft skill webinars, which we work with Clearly Blue Both, who runs these soft skill sessions like art of effective communication, how to build that winning resume, and how to ace that interview, etc., once a month. And we work with Clearly Blue Both, who runs these soft skill sessions for us. Apart from that, we also get the Tara graduates to share their experience of the program and how successfully they completed the program, and are placed in various organizations, and how happy they are about being placed in a organization. So these are few of the hand-holding mentoring sessions that we do with the Tara candidates once they register, of course. And a recording of all the webinars are available on the VMware social channel too. That's how the Tara web page interface looks like. So you have all the FAQs. If you have questions, like if you're eligible, or anything for that matter, you can go through the FAQs and you can enroll if you feel you're eligible, or you can also write to us at tara_vminclusion@vmware.com, and we can help you out to let you know that if you're eligible or if you can go through the program. Now, if you are a woman who is already working, or if you know of somebody who is on a career break, you can be a Tara evangelist. What you can do is you can like or share our posts on LinkedIn or other social media handles, and help us outreach to those women who are in need, and who are on a career break and who want to get back to the workforce soon. So just to reiterate, VM Inclusion Tara is a upskilling program for cloud computing, cloud computing and virtualization for women who are on a career break for more than 6 months. So please do reach out to us if you have any queries. Tara at Tara_VM Inclusion at VMware.com. That's it. If you have any questions, you can write to us or reach out to me, and I'll be able to help you out. Thank you so much, Nitya.
Thank you so much, ma'am. I think hearing about the program is really inspiring in a way, because it's genuinely helping the people who actually need it. The women, the audience is a lot. The target audience is a lot. There are a lot of women who leave their jobs because of different circumstances, and I think it's a very amazing initiative that VMware has taken up. So thank you so much for sharing that information with us.
Thanks, Nitya. So we have reached the half milestone of 8,000 plus women registering for the program, and we intend to outreach to many others who are still looking for an opportunity to go ahead and enroll themselves or come back to the workforce after a career break. All the best, and thanks again.
Thank you so much, ma'am.
Thank you.
So now we have our next speaker with us. Her name is Ms. Soma Das, and she's a data scientist practitioner and subject matter expert mathematics, and she's going to be talking about AI in education. Thank you so much for being with us, ma'am.
Thank you, Nitya, for the nice introduction. I hope I'm audible and visible too.
Yes, ma'am, absolutely.
Okay, let me share my screen. Okay, so my screen is visible too, right?
Yes, ma'am.
Okay, so I would like to begin with congratulating the women in data science Mysuru team, first of all, for coming up with such a great platform that celebrates women in celebration, and the month-long celebration that had been going. I have been following it, and I really congratulate you guys for the good job being done. And I am truly honored and delighted to be a part of WiDS talks today. So today I will be talking about AI in education in India, how it is being implemented, how it can be implemented, what all can we do about it, and every aspect about it. So beginning with it, I would like to give a short introduction about myself. I am Soma Das. As Nitya said, I am a mathematics subject matter expert by profession and a data science practitioner by passion. I am basically on a journey of growing from academia to data science, taking little little steps one by one. And in this journey, I have realized the power of community. So I believe in giving back to the community while I am learning from it. And on that path, I am also an organizer at Kaggle Days Meetup Delhi NCR, which had the privilege to host Ms. Usha Rengaraju herself this month. And we were very delighted to have her on board. So let's get started. I'll brief you the agenda for today. I'll be talking about 3 things, like why we need AI in education, what is the current scenario, how AI is being implemented in education in present, and what more can be done to implement it in the future. how our government is planning. And all of this I am centering in India, since we know education builds the future, so and AI is the future. So how these two can be amalgamated today, that is what we are going to see today. So why we need AI in education? Okay, then I'll begin with some stats. According to the statistics given by the Human Resource and Development Ministry of India in 2016, there is a shortage of 1 million teachers across the country. In case of universities and colleges, there is a chronic shortage of faculty and problem of finding qualified people to fill this gap. And it has become more complicated as the population is rising every day. In such a scenario, how can India, a country with the second largest population in the world, cope with the challenge of providing quality education to all? So I'll also discuss the possibility of, can AI replace our teachers? Because there's already a shortage of teachers. Do teachers need replacement, or assistance to them would be of more value? So in our current education system, there are some problems and some proposed solutions to them as well. One of the major problem is low retention rates. According to some stats, 4% of the students drop out of school in the primary level only, which goes up to 20% when they go up to higher education. And when we can't retain students to school, when we can't retain children to the education system, there is no point of making advancement in it. There is we can incorporate AI in it, we can replace teachers with AI, but there is no point if we can't retain teachers in the students in the schools. Second problem is, amongst the students who are retained, the outcomes are very poor on an average. There is a lack of interactive pedagogy. Remedial instructions are ineffective. There is a curriculum that is followed year by year and not reflected upon where it needs to be corrected. Inadequate attention is given to the likely dropouts. There's a large teacher vacancies, as I said, 1 million lack of teachers across the country. Professional development is lacking, and existing technologies are not being adopted on a larger scale. That may be due to the lack of, lack of infrastructure, lack of training. Whatever be the reasons, they need to be looked upon to improve the current education system. And here in this side, there are some proposed solutions, that is adaptive learning tools to customize learning, intelligent and interactive tutoring system, predictive tools to inform that there will be students who will be dropping out, then taking remedial steps about it. A rationalization of teachers is required, and most importantly, even if we are developing, the teachers need to be trained according to it. So while I use terms like predictive tools, automated rationalization, can you guess where AI can play a role in the current education system in India? That is what I am talking about in my second topic, that is how AI is being implemented in education today in the current scenario. A beautiful initiative has been taken up by the Andhra Pradesh government, where they are using AI to identify potential school dropout rate in Andhra Pradesh. Like I said, it's about 4% in the primary education, which goes up to 20% in the higher education, and there is a high need to retain students to tackle the dropout rate in the country throughout. And for this, in December 2015, the Andhra Pradesh government signed a memorandum of understanding with Microsoft to use AI technology and for addressing the issue of school dropouts. Now, what is this memorandum of understanding? By using Microsoft's Azure machine learning platform, an application was developed which helped the state education department in predicting school dropouts. When we predict school dropouts, we can cure it. When we know the issue ahead, we can take remedial steps towards it. Now, how does this application do it? The application processes the complex data. The variables it uses are details about enrollment, student performance, gender. Gender plays a very important role, as we all know, their background, socioeconomic demographics, social infrastructure, teacher skills as well, and to some extent the infrastructure, the locality they are being living. The application processes all this complex data and predict patterns about dropout. The output has been, it has proactively identified the potential dropouts, and not only that, it has given an analysis of critical factors responsible for the issue. More than 60 patterns were identified, which helped in tracking dropouts and taking steps towards it. The second application of AI in education would be Tara. Now, what is Tara? In 2016, G. Ramamurthy, Gauri Mahesh, Saraswati Ramamurthy of the company Learning Matters came up with Tara, which is an interactive personalized teacher assistant. Now, I'll highlight the point teacher assistant here. AI is yet to replace teachers. Teachers may need assistance in education, but as of now, AI is not ready to replace them. Now, what is Tara? Tara is a dynamic two-way interactive teacher assistant that uses artificial intelligence and natural language processing, that is NLP, to create an immersive learning experience. How does Tara operate? Tara is extremely light on hardware. Only it can operate on a smartphone, on a voice-enabled device such as the Echo Dot, even on Amazon Alexa. It requires only a minimum 3G connection to function effectively, and that's it. And there has been records where the government schools are also using it on their using 3G connection on their smartphones as well. And how has been the output? During this difficult times of the pandemic, it has been very instrumental in solving the challenges in continuing the education of children, because it has supported online teaching and learning through the voice technology. And how does she act? When you get a wrong answer, she patiently explains why it was wrong and what the correct answer was. And when you get the correct answer, she obviously acknowledges it. Now, a lot has been done in the public sector as well in education. I'll cover four use cases of this. First being Topper. Topper is an Indian education technology and online tutoring firm. It again uses AI and machine learning to outline students' qualities and shortcomings, individual learning rates, records, support of kids' confidence, their zones where they are strong, where they are not strong, they are weak. It gives it studies that data and enables the kids to stay encouraged and motivated. Basically, personalized inputs to the students are given. Then comes EduGorilla. EduGorilla empowers students. It's a one-stop shop for everything education situated in India. It utilizes AI and analyzes big data in the education business system. It analyzes data from around 6 lakh schools and 70,000 instructing centers to give high quality outcome to Indian students. Next up, we have Imbibe. Imbibe Imbibe is for high pressure exams like NEET, AIMS, CBSE, JEE, Mains, JEE Advanced, BITSET. And what are the variables it studies are performance metrics. It analyzes the student's weakness centered and performance matrices like accuracy, speed, which are very crucial in examinations like this. Speed, time, management, stamina, attempt planning, confidence for high pressure exams. All of these are assessed and analyzed depending on the students, and then they provide remedial measures for this. Imbibe has been doing very good, and the Reliance Industry Limited has executed a definite agreement to acquire majority quality stake in Imbibe. And thus, Imbibe has got some bright future ahead, making the future bright for the students as well. So moving on to Leverage Edu. Leverage A2 again uses AI to help students on their platform to figure out what's right program, college fit for them, where can they get to, what would be good for them, what mentors suit them. Basically, essence, a student is working with someone. So basically, they access the holistic approach of a student and again, personalized. So a lot more is happening in the education sector. A lot more can be talked about. I'll be giving all the sources where you can read more about it. And Imbibe has given its stats all over the how they have improved the performance of the performance of the students. But currently the clock is ticking, so I'll move on to the my last and third agenda: what more can be done to implement AI in education? What is the future of AI in education countrywide? So, according to an article by Niti Aayog, it has claimed that Indian education sector is ripe for disruption by artificial intelligence. Now, to support this claim, it has given various pointers which we'll be looking at one by one. So, one of the targets under the agenda of quality education says that by 2030, our nation must substantially increase the support of qualified teachers. By meaning of supply of qualified teachers, it may not be possible to fill the large demand supply gap that exists, but it is possible that the teachers are made more efficient. Teachers are assisted. The job of the teachers is shared by AI. So here are some ways AI can do so. So the drum roll. This I found very interesting, the real-time text-to-speech and text translation systems. Now, what is this? The draft of National Education Policy 2019 has encouraged the learning of mother tongue languages. And this real-time text-to-speech and text translation systems can be integrated in Diksha, which is the digital infrastructure for knowledge sharing that has been set up by the MHRD, or the e-Pathshala initiatives under the Sarva Siksha Abhiyan. And how it will help. Suppose there is a textbook in e-Pathshala and that is available only in Hindi. Now, using text translation services, that can be made available into other regional languages and made more accessible. How it will help? The language barrier could be removed. The same resource can be used multiple times throughout the country. It will help in meeting the demand. Interoperability of teachers across state can be achieved. Like, for example, a teacher has created content in Hindi or in Gujarati or in Bengali, and using the real-time text-to-speech and text translation systems, it is converted to all the languages and it is accessible to those. It is a huge assistance to the teacher who will not have to create repeatedly the same content in their own languages. It will help to save our resources as well. Second is automated grading. A lot of time of the teacher goes into grading, and in considering the quantum of students available per teacher is quite huge, and when teachers are focused more on the grading part, they tend to lose their focus on the remedial measures, on assessing the students on the ground level where they are lagging. Again, the draft of National Education Policy 2019 is prioritizing online learning. So machine learning methods such as natural language processing could be used for automated grading of assessments on a large scale on the same platforms Diksha, ePathshala, and Swayam. Swayam is study webs of active learning for young aspiring minds, and not only in objective questions like MCQs, etc. It can assess subjective ones as well. NLP techniques will be used. The claim says will be used to use automatic text summarization to create crisp content and publish them on these e-learning websites, saving teachers a lot of time to look into matters they require to concentrate. Then our pattern detection to increase inclusiveness. Children with special needs, children affected with autism, Parkinson's disease, any disease that results in a speech disorder can benefit by integration of machine learning models in the e-learning websites that detect speech patterns or augment the speech by correcting mispronunciations or broken words, and then output the same in an audio or text format. So this can help in pattern detection that would increase inclusiveness among students. Personalization has been quite achieved on a private level basis on some states, but BT Ayog is planning to work on implement it country-wise. That is educational infrastructure powered by AI that would give each student of India a personalized teacher or tutor. These are three more points on that: supervised classification models to reduce dropout rates, like Andhra Pradesh government has done it. It can be done nationwide. ML models can be used to predict the children that is dropping out, and proper redressal mechanisms, of course. Biometric authentication is again a mundane task the teacher has to do. We can help them get rid of that. It can be introduced and integrated by unified district information system for education. That is one of the largest management information system on school education, leaving the teacher more time for creative work. And last, chatbots. The AI is visualized always as chatbots, though AI is much more than chatbots, but then chatbots can be trained on subject matter. A good percentage of doubts students can be answered instantly, creating a huge support for teacher. This is being done by the private sector, but the government is planning to do again on the nationwide level. That's all from my end. These are the sources I have used in my presentation. There is a lot of information that is available in these sites. I could incorporate only the important one considering the time constraint. Thank you for hearing me out. You can reach me out at LinkedIn if you have any questions, any queries. You can reach me out if you wanted the sources. You can contact the hosts of the event. Maybe I'll make sure that I'll give them the PPT, or you can reach me out directly for any questions or queries, or maybe suggestions. How can I improve the next time? Thank you so much. I had a good time. Hope you had too. Over to you.
Thank you so much, ma'am. That was a very informative session. I mean, as a student, I can honestly imagine all of this happening in the near future, because it will make the lives of teacher a lot more easier, because India does have a very big student population, and we do need these kind of technology so that it caters to every individual person on a very personal basis. So that was a very informative session. So thank you so much for being with us, ma'am.
Thank you for having me.
Ganesh, would be great if you could introduce our next speaker.
So I would like to introduce our next speaker for the day. That is Soumya Jain. She is a data scientist at MIQ, and the topic that she'll be going to handle today is unsupervised learning approach for identifying retail store employees using footfall data. I would like to thank you, ma'am, for being with us.
Hello everyone, my name is Soumya and I work as a data scientist at MIQ Digital. Today I will be talking about an unsupervised learning approach for identifying retail stores employees using footfall data. Before diving deep into this topic, I would like to brief you about MIQ, what it does and how it does it. So MIQ is a programmatic advertising company. We are expert in combining real world and digital data and applying marketing intelligence to give our clients the insight that helps them win. Moving on, my agenda for today's talk is as following. First, I will start with a brief overview of programmatic advertising environment. Next, I will move to location data and explain you how it is used in advertising. And then I will be talking about my ML approach for detecting employees out of stores. From next few slides, you will know how these topics are connected to each other. So let's start with programmatic advertising. So programmatic advertising is buying ad slots on internet and connecting the advertiser to the consumer via a software. Let me tell you how this happens. Suppose a user goes to a website. For example, it's the user search xyz.com in its browser. And in the duration this web page is loaded into user's browser, the owner of the website tells that there are 3 ad slots available in the web page to an ad marketplace. So there is a communication that happens between the owner of the website and ad marketplace, and this communication is for letting ad marketplace know about the ad slots available. In ad marketplace, there are ad slot buyers like MIQ who bid for these ad slots. A real-time auction takes place and highest bidder wins. And the winning bidder ad is presented in the ad slot. This entire process takes less than a fraction of a second. So just in time a web page is loaded, all this process is completed in the backend. Amazing, isn't it? And the scale of the data in this environment is also pretty huge. So almost 40 billion ad slots are traded daily, and the transaction generates 20 terabytes of data in companies like MIQ. So you can imagine how much of data that we are tackling with. Now, there are various parameters like online browsing, offline location, demographic of users, which helps in understanding the consumers and getting right users for clients' ad. One of this is location data, which will be a part of hyperlocal advertising. And from here, I will be talking about footfall data and hyperlocal campaigns. So let me tell you what is location data. So location or footfall data is basically tracking of users that enter a physical store through a device that user is using. This data lets you know the way people behave in the real world, who they are, and where they spend their money. So location data is a powerful strategy for finding most valuable customers for the client. Here is an example of a user who visits certain places over a day. We don't know at what time that person is visiting and why that person is exactly visiting that store. By leveraging location data, we now know at what time that person is visiting. Also, we are able to create a story behind the person's movement. Using footfall data, we are able to we are able to understand the behavior of a user, build useful insights of this user, and ensure that ad are served to right person, if that person is right or not, to serve clients ad. So this was an example for one of the user. Now let's imagine that there is a client which wants to run a hyperlocal campaign. A hyperlocal campaign means a campaign which tracks data, which tracks user physically. Like it tracks the physical movements of that user. Now let's understand at a campaign level where we need to track multiple locations and collect information about millions of users, how this happens and how the most valuable customers are shown ad. Suppose MIQ has a client, a supermarket client, let us call it S Market, which wants to run an in-app campaign with us. First, we will provide them with an existing insights, which is pre-campaign intelligence. These insights will be like top competitors of this S market, peak time the users are visiting the supermarket. This is possible through footfall data and POI infos. The next stage is targeting. So using the learnings that we have got from pre-campaign insights, we target right kind of audience at right time by running clients mobile campaign, that is showing ad to the user. The next step is to measure the performance of this campaign by leveraging following data sources like footfall data, audience data, app data, and macro factors. At the same time, when we are building insights and measuring the performance, we are also trying to optimize our campaign to get more valuable audience. So as you have seen, we are making our campaigns more effective with time and our machines more intelligent by studying footfall data around the physical stores of the client. If the data is not robust, our insights will not be accurate. The challenge we have with footfall data is that in and around physical store, there are passerby users, there are employees, which are not the customers and should not be used for building insights or for tracking. They are noise to our data. So moving on to our third topic, which is how we can remove this noise from our raw footfall data. To make our insights robust, we are cleaning out the employees, passing by users, and other kinds of users that are not customers to our clients. Here are some insights that can have impact of having employees in the footfall data. So first is visitation frequency. These reports tell you percent of users visiting the store over a month and number of times they are visiting. For example, 20% of visitors visit twice. If there are employees in this, then number of users in 6+ bucket will increase, and as employees visit daily. The next is daytime analysis. This report tells you at what time of the day how many users visit a store. So here, afternoon is a peak time for this store, with 60% of users visiting at afternoon. And the second is evening, where 24% of users are visiting. If employees are present in this data, the numbers in each bucket will increase. Their flow will remain same, but numbers will increase, and through customers number we won't be able to provide. So we have to make sure that our data is cleaned. Footfall data is tracked through apps SDK. There can be many errors while data collection, like polygon map tracking error, where shape of the store is not mapped accurately, or device signal error, because of which accuracy with which the data is received and collected decreases. So in such cases, single parameter model will not work. Like if we want to remove employees from a store, in a simple way, we can create a filter like people who are visiting 20 or more times over a month can be considered as employees and can be filtered out. But because of this errors, we cannot use a single feature to decide. So here we are using a multi-feature ML-based approach to clean noise out of the data. We have used an unsupervised model. An algorithm that is used is dbScan. So dbScan is a density-based spatial clustering algorithm which removes noise by making clusters of points using distance measurement and minimum number of points. And it marks as outliers the points that are in low density region. Let me explain you with this graph. So here all these points are users visiting a store. Now they are clustered using this DB-scan model. So all the clusters are based on our features. They are the customers who are look alike, having same kind of behavior, and are clustered together. But their behavior is kind of different from each other. So a red cluster's behavior is different from orange cluster in some of the features. Then there comes black points. These black points cannot be grouped to any of the clusters, and hence they are in a low density region and can be considered as employees, which are noise in our data. The features that we have used in this models are following. First is visitation. So number of times a device got recorded in the store versus the total recorded visitation of that device throughout the data is termed as visitation. Duration of hour, average of time spent by a device in a store on a day over a month. Counts of day. Counts of day is number of days user visited the store over a month. Frequency of continuous data. So number of times devices visited continuously on a store over a month. So customers will not, there is a high chance that customers might visit less frequently, but employees have to visit frequently, like Monday, Tuesday, Wednesday, every day they have to visit. So this feature can be useful in marking the distinction. Next is count of months. So in 9 months of data, count of month when devices came to the same store again and again. Similarly, frequency. So count is like how many times that that device has visited the stores, and continuous frequency means how many times continuously, January, February, March, how many times continuously that device is visiting the store over months. So these are the total features that we have used in our model to decide if a device is an employee or a customer. For removing passerby users, we have used a filtration technique because passing by users will not remain for more than 5 seconds, 6 seconds in and around the stores. So clearing them out using duration was an easy task, but for employees it was not very easy, and that's why a ML based approach has to be used. Next is model validation. So for this unsupervised learning model, we have used silhouette coefficient. Silhouette coefficient values lies from -1 to 1. If the value is 1, that means our clusters are compact, dense, and are well separated from each other. If the value is close to 0, that means clusters are kind of every cluster is kind of close to each other and less compact. Value when reaches to -1, that means clusters are overlapping. So when you see that right graph, you see that the silhouette coefficient is 0.6, and clusters are quite dense and there is less number of noise that is available. But as you see in left side, the silhouette coefficient is 0.2, and there are a lot of noises that are generating that it is getting generated, but it is not possible to have 67 employees in the store. So by the time the model improves itself, its silhouette coefficients also gets improved, and the number of noise is getting reduced, and so that means that number of employees is getting reduced and true employees are coming out of this model. Now we have run this model for a brand which has in total 12 stores across the country. For each store, we were able to get X number of customers and Y number of employees. For example, for store 1, we were able to get 800 customers and 6 employees. So on average of this 12, we were able to get like 600 customers for each of the stores and like 4 to 5 employees for each of this store. We were able to create a clean distinction between employees and the customers. For example, number of days employees visit over a month in a store is 14, but customer only visit 3 times. Time spent by a employee is 4 to 5 hours in a store, but for customer is only 1 to 1.5 hours, which makes sense. Similarly, in other features also, there is a distinction that we can see. Now here is a sample output. So for each identifier, we have the value for each of these features, and at the end we have label based on the model result, whether that device is a employee device or a non-employee device. Non-employee device means it's a customer. Now moving on, we can see the impact of this model of cleaning the data and removing all the extra noises, what it makes on our insights. So yellow bar here represents values before cleaning, and orange depicts after cleaning. So this is day part analysis. So here we are seeing that at what time of the day, what percentage of users are visiting the store. So at afternoon, before cleaning the model, 47% of users are visiting, and after cleaning our data, 46% of users are visiting. So there is not a big difference that we are seeing here. So from morning to night, we are not able to see a big difference. But when you see late night, there is a clear distinction, because late night there is a less chance of customers visiting the stores, but if the store is open, employees will be available. So there is a decrease in the number of users in the store at that time, at late night. The next is visitation report. So here we tells that how many times a user is visiting. For example, 79% of users were visiting once in a store. Now, even after removing employees from our data, 79% of users are visiting once, which makes sense because employees will not visit once or twice or thrice. But there is a difference again, there is a drop in 5 plus bucket, because there was a high chance of employees generating wrong numbers. So after removing employees, we were able to see a clear drop of 2% in our insight. With this, we come to end of my session. Hope you enjoyed it and learned about programmatic advertising, footfall data and its importance in advertising world, and unsupervised way of cleaning footfall data. Let me know if you have any questions. Thank you.
Thank you, ma'am. That was quite a lot of information, and I'm sure it will be useful to many of them. Now, I would like to introduce the next speaker and the last speaker for the day, Sulakshana Sriram. Ma'am is going to talk about her journey in WiDS Hyderabad as an ambassador.
Actually, we are having a bit of a technical issue, so please stay with us. Just give us a couple of minutes. We'll just correct that.
Good evening, everybody. I'm Sulakshna Sriram, and today I'm here to share my interesting and adventurous journey, I would say, as a WIDS Hyderabad ambassador. Firstly, I would like to thank WIDS Mysuru ambassador for inviting and giving me this opportunity to deliver this short talk. Very brief about myself. I am associated with Sri Vishnu Educational Society, a group of institutions in the higher education space that operate out of Telangana and Andhra. I lead a division here called GSSC, Graduate Study Abroad Center, and in parallel, I'm also an assistant director for industry relations at our society. I'm an MBA specialized in human resource management with no technical skills. This is my journey from being completely new to the field of data science and also organizing events to a hands-on event organizer and decent knowledge in data science as well. This was last year, 2019 March, when I attended one of the regional WIDS conferences and was totally carried away by the enthusiasm of the organizing team, the wonderful women speakers who have done such an outstanding work in the data science space, and of course the audience who were so pro, engaging, and open to learning new things. My research started there, and fortunately I came to know that WIDS chapter wasn't there in Hyderabad. I immediately wrote to the global WIDS team to inform them and ask them if I could nominate someone from my organization, which is an educational institution, and there are many faculty with good technical knowledge. The next day, I received an email from WIDS Stanford thanking me for showing interest in the conference and encouraged me to be the ambassador for Hyderabad chapter. I had mixed feelings. I was glad, I was confused, surprised, and totally blank. Then I thought, why not? And started my research yet again. Things moved very quickly. The global team asked me to give them a draft on how my event would look like, as in the topics, speakers, timelines, and venue. There I was standing with an open offer to organize one of the prestigious women conferences of the globe, and I had no clue what to do. I gained all the courage, and the first person I spoke to was Ed HR Deepti Verma of Amazon. She heard out and just said, Amazon will host the event. I gained so much confidence that I spoke to so many organizations, met a lot of prominent people to request for sponsorship. Then came in VHub into picture, who very gracefully agreed to be our sponsors. I googled a lot about what data science is, what's the latest happenings there, who are the women in the field. I slowly started reaching out to them. I started receiving confirmations as well, started participating in discussions with them on how AI, ML, and deep learning have disrupted the market by diluting the current jobs and at the same time creating new roles. Now I had the venue in hand, few confirmed speakers with top topics too, shared it with the global team. The next day, what I received is the license to organize the event in Hyderabad. I never looked back, immediately formed my core team. I wanted to make it very unique and memorable for our audience, hence finalized ethical papers as our stationery vendor. I wanted to make it more memorable and unique for our audience and speakers and all of us. So we went ahead and finalized some of the posters. And every statement in the poster, I really mean it right from the heart. Women is the force. Women is the solution. We are the trend. We are the change. We are the future, the celebration, the inspiration, the reason, the quest, the movement, and the story. Every statement in the poster, I mean it right from the heart. We moved towards finalizing some more speakers and their talk topics, then moved on to the registrations. And here comes the D-Day. February 15th, 2020, Saturday, an off day, ladies and gentlemen, and please note, venue is at the corner of the city, yet it was a full house. We received so many applauds. So many approached us, so many people approached us to be part of the core team. So many organizations approached us to partner with us on the hosting front. To make it It was such an engaging and interactive audience we had. Many encouraged us and thanked us for creating such a platform where they could network. The audience were fantastic. They were so much engaging and enthusiastic. To make it even more fun and frolic, we planned classical performances by the students of BVRIT College of Engineering for Women in Hyderabad. It did not stop there. The global team invited me to be a part of the global conference on the 2nd March 2020. The pandemic was slowly spreading then. I did not have my visa too. They sent an invite letter that could be used at my visa interview, and my organization, Vishnu Group, encouraged me by sponsoring my trip to Stanford. I came back on the 11th March, and all the international flights were cancelled from the 18th March, and 22nd March or so, it's lockdown. It was a great learning, great experience, great start to a new beginning. I started off from nowhere and reached a place where I'm one of the successful WIDS regional event organizers. I even launched a data science center of excellence in our institutions, where some of the companies who are strong in data science have come forward to initiate diversity skilling programs. I enrolled myself in a course by the name Introduction to Data Analytics for Business Operations with University of Colorado Boulder. Very soon, I'll be a certified data analyst for business operations. My giveaway message tonight is that to be open to challenges. You will know what your potential is only when challenges are thrown at you. All of us are strong, all of us are confident, very capable, but when would these qualities come out of us? It's only when you face challenges, difficult times. Never run away, face it, overcome it, and experience the bliss. This is my WIDS Hyderabad first conference journey. Would like to present a glimpse of WIDS Hyderabad event before I sign off. Here it goes.
So a very warm welcome to all of you on the first Women in Data Science Conference. And it's a great pleasure for us here at Amazon to host you today.
I would like to thank Amazon for telling that, yes, you can go ahead, we will be the venue partners. If I wouldn't have heard that yes from Amazon, today this conference wouldn't have happened. WIDS Hyderabad chose ethical paper for today's conference. You'll find it in your entry kits, a spiral book and a pen and bag. So ethical paper is 100% post-consumer recycled, free from forest wood, FSC certified.
Yeah, I guess we are having some technical issues while playing that particular video. So if you could just give us like 5 minutes, we'll try to figure it out and play the whole thing.
So a very warm welcome to all of you on the first Women in Data Science Conference. And it's a great pleasure for us here at Amazon to host you today.
I would like to thank Amazon for telling that yes, you can go ahead, we will be the venue partners. If I wouldn't have heard that yes from Amazon, today this conference wouldn't have happened. WiDS Hyderabad chose ethical paper for today's conference. You'll find it in your entry kits, a spiral book and a pen and bag. So ethical paper is 100% post-consumer recycled, free from forest wood, FSC certified. By choosing ethical paper, we are helping ensure a sustainable future for all of us and for the natural world that supports us.
So at the outset, thank you so much for taking the initiative to do something really important and relevant for everything that we are trying to do.
Thanks a lot, everybody. I would like all the speakers, all the sponsors, all the audience for being here, for attending this first conference. Thanks a lot.
I once again thank the WiDS Mysore ambassador for inviting and giving me this opportunity. I wish everybody good luck for your endeavors. This is Sulakshna Sriram signing off. Have a great evening. Thank you.
Thank you, ma'am. That was an amazing story about WiDS Hyderabad, and I would like to thank you for sharing your experience with us.
Okay, so now we have come to the end of today's event. So first of all, I would like to thank all the speakers for taking time out of their busy schedule, and thank you for gracing us with your presence at WiDS Mysuru. We would also like to extend a gracious thanks to the management and the faculties of the four collaborating universities, NI Mysuru, VVCE, GSSS, and GSSS for supporting us in our journey. And I would also love to give a huge shout out to our core team members, the organizing team of WiDS Mysuru, and all the volunteers for helping us organize this meticulous event. Ganya, over to you.
Yeah. I would like to invite you all for our next event, that is tomorrow on 26th September at 11:15 a.m. You all can even subscribe to our YouTube channel for getting notifications quickly, and you can RSVP us for the event to get a participation certificate. I thank you all. Don't forget to join us tomorrow, and you'll have an amazing events with inspirational women in data science coming together. Thank you.
Thank you so much for taking time out of your schedule and being a part of WiDS Mysuru. So stay tuned. We're going to have amazing, inspirational, extraordinary, gorgeous women talking about their work, talking about their experience, giving talks and workshops for the next 2 days. So we have a great lineup for you. So stay tuned with us. Now I will end the live. Thank you so much for being a part of today's event.